privilege of bringing together some leading minds, researchers, and innovators from different parts of the country, having a future into science and technology. This session promises to be an inspiring platform for sharing groundbreaking ideas, innovations, and fresh perspectives. To set the tone of this session, it gives me immense pleasure to introduce our theme coordinator, Professor Shantanu Chaudhary, a visionary academic leader and a luminary in the field of computer science and technology. Professor Shantanu Chaudhary is a Schulenberg Chair Professor in the Department of Electrical Engineering at IIT Delhi. He previously served as the Dean of Undergraduate Studies at IIT Delhi and was also the former Director of IIT Jodhpur. A distinguished alumnus of IIT Kharagpur, Professor Chaudhary has authored over 350 peer-reviewed journals and holds 15 patents and is a fellow of INAE, NACI and IAPR. His research and leadership continue to shape India's academic landscape. We are honored to have him with us. Please join me in welcoming him, Professor, who will be introducing our session chairs and will coordinate the technical sessions.
Thank you. Let me welcome all of you to this section of Engineers Conclave. And here we are looking at primarily interdisciplinary cyber-physical system as a theme, vis-a-vis the other theme which has been on intelligent systems. And as you have seen that as we were discussed in the inaugural session, the intertwining of the two themes are very critical in terms of future technology progress and growth. So in that context, I think this stream gets a specific significance, because as it's very clearly established that if we really want to generate technology, we want to have technology reaching the life of people, it has to be transformation of cyber physical system, because cyberspace and the physical space has to come together, and that's where the human being is connected, and that's where the human life is impacted. So therefore, that gives the significance of these particular stream of discussions and debates that we shall have as part of this technology conclave. To start this, we have now this session on sensors and IoT, and we have it to be chaired by Professor Jamil Akhtar, FNAE, from IIT Kanpur. Jamil is a very well-known scientist in this space and who has actually guided, since he's a professor, I'm just putting that first, has guided about 25 PhD theses in this area. He himself is a PhD from University of Magdeburg in Germany, and he also he was also a postdoctoral research scientist and a project leader at Karlsruhe Institute of Technology, Germany. He's a fellow of IEEE, fellow of Indian National Academy of Engineering, and a fellow of IET. He's a recipient of Excellence in Teaching Award in 2021 from IIT Kanpur and CST University Publication Award in 2009 from CST AG Darmstadt, Germany. He served as an associate editor of IEEE Sensors Journal during 2020-23 and is currently serving as an editor of IET Technical Review, the IET Journal of Research, and Sadhana, the Academy Proceedings in Engineering Journal. So Jamil, let me welcome you to coordinate and chair this session, please.
Very good morning, and thank you, Dr. Chaudhary, for your introduction and being here. So I welcome you all to this session. So as he already mentioned, the session is on IoT and sensor nodes. If you see the basic theme, it is well within the theme of the workshop, the cyber physical systems, because as of today, if you see, sensors are everywhere, and IoT, most of you are aware, like we try to connect every device with the Internet of Things. If you see IoT itself, it has both hardware and software, Like you want to sense temperature, you want to sense the movement, want to sense humidity. So you need a physical structure, and at the same time, when you want to connect all of these sensors together, you need something like the software, and also you want to monitor, for example, on your app, you again need a software. So, but, I mean, as Dr. already mentioned, the theme is quite relevant into this scenario because both cyber and physical, they are important from that perspective. In this talk, we have three very excellent, in this we have three excellent talks by different experts, and they will balance it in the sense that they cover many topics. We start with the first talk, which is on RF energy transfer and efficiency. Then we have a talk on biomarker, and finally we have talk on flexible gas sensors. If you see, like starting from your wireless sensor nodes to what we call the RF energy with a transfer with a very good efficiency, and then the bio application and the printable electronics. So we go with the first talk, which is will be given by Professor Suresh Kumar Dey. Professor Suresh Dey is a professor in the IIT Kanpur. I'm sorry, IIT Kanpur comes to my mind first. He is a professor at IIT Delhi in the Department of Electrical Engineering. He was also a professor earlier with the Department of EC, University of Technology, and he worked as postdoctoral fellow in Italy at ISTI CNR. Apart from academia, he also has industry experience in telecom hardware and software. His interests are in communication network with emphasis on modeling, spectrum sharing, and IoT communication, including smart grid networks. He is a fellow of INAE, INSA, NACI, and ISC. He is a recipient of Abdul Kalam National Technological Innovation Fellowship. He currently is working as editor of IEEE transaction on wireless communication, associate editor of IEEE transaction on medical technology, and IEEE wireless communication magazine. He will talk today on enhancing efficiency of radio frequency energy transfer. And as you know, like as of today, wireless sensor nodes are used everywhere. They are part of IoT network, and one of the challenges is how can we energize this sensor network to increase the lifespan. And Professor Dey will talk on this. Thank you, sir, and I welcome you to the podium.
Slides can go. Yeah, okay. How do I make it full screen? Full screen. Yeah, this is not. This is not PPT.
Oh,
Okay. Okay. Thank you, Professor Chaudhary, for inviting me, and Professor Akhtar for introducing me. So this topic is coming from the plenary session. This topic might look a little bit odd because it has little to do with AI as such, but I think this topic is very well placed in terms of sustainability, energy sustainability, and so what we are looking at, in fact, some of the motivations that I have here are a little bit old. In fact, I will also motivate with respect to the modern approaches that people are actually using for wireless energy transfer actually. So in fact, in communication network, whatever we do, we have been working on these energy optimization so at different levels actually, media access control, routing protocols, etc. But at the end of the day, there is a constraint of energy, limited energy of these devices actually. These devices could be miniature sensors. Also devices could be, or systems could be as large as wireless base stations actually. Today people are talking about how to recharge wireless base station wirelessly in a controlled way actually. So of course there are other possibilities of, normally what happens is that in miniature devices, these are connected, these are battery powered, and battery power is limited, so you have to recharge somehow. And on the other hand, there could be, let's say, grid connected wireless base stations, and we are also talking about the solar connected or ambient connected, etc. But ambient powering is actually not always possible. Basically, there is a non-deterministic constraint. So as a result, there are situations where we need to actually dedicatedly supply energy. Okay, so that could be a wireless sensor node as well as this thing. So this is what I pointed over here. This is it's not visible. Okay, random nature of energy, etc. Kind of stated these things. So RF energy harvesting and wireless energy transfer is with regard to the availability on demand. So one can actually think of when to supply energy actually, and one-to-many charging is possible. So in fact, if I look at our topic is wireless energy transfer, but wireless energy transfer from another angle, we can view this as kind of a magnetic coupling or your inductive coupling based approach. In fact, our EVs are working in that principle actually. There the constraint is that the distance between these the transferring agent and the agent where the body where energy is going is on the order of millimeters, and alignment has to be very perfect actually. Whereas there are situations where we need to have these two entities might be far apart and maybe mobile, and so as a result this kind of directedness is not possible actually. So this is where these radiative energy transfer is coming into play actually. Now radiative could be again classically from wireless RF perspective. Also radiative could be from optical perspective. In fact, towards the end I will actually motivate how this is relevant in that direction as well actually. Okay. So, this is actually what people have been already talking about. This RF energy transfer, that this base station is let's say directing energy to these different sensor nodes, and also there is something called SWIFT, simultaneous wireless information and power transfer, wireless powered communication network. So one thing that as we will see in the process is that these concepts actually have been presented in the literature possibly in late 2010s and to the 2020s also, but some of the concepts are actually practically not feasible. In fact, we will try to motivate in that direction. For example, what we are talking about, what is being conceptualized is that there is a wireless base station which is going to supply energy to the mobile node as well as it is going to transmit its information. That is called SWIFT, simultaneous wireless information and power transfer. But the communication range that we are talking about is on the order of 100 meters at least, right? In wireless cellular communication range from the base station to the nodes could be on that order actually. And in our experiment and through our discussions, we will see that this is actually practically not feasible given the state of the art and the constraint of wireless harvesting, the RF harvesting actually. So this concept is actually practically infeasible, although there are multiple papers, possibly tens of papers have been published. Likewise, wireless powered communication network is, the theme is that there is a sensor node which is going to collect, let's say, ambient information, and but sensor node has to be charged. And the concept is that the base station, or it could be drone also, it transfers energy to that node, and in turn it also collects the information. So wireless powered communication network. Again, given that asymmetry of this communication range for information communication can be very large as possibly, let's say in cellular communication could be 20 kilometer actually. So why? Because the efficiency of communication, efficiency of information extraction is what the minus 90 dBm, minus 110 dBm, etc. Your sensitivity could be as low as this much actually, whereas sensitivity for wireless information transfer could be today is about minus 20 dBm, minus 30 dBm. The Nagarjuna researched on that actually. So minus 30 dBm versus minus 110 dBm. So we are talking about several orders of difference actually. As a result, this is also practically infeasible, this WPCN. So these were some motivations people have actually thought, theoretical people have thought actually. What we were looking at, in fact, our thought process, this is quite a chain of work actually. We were thinking that okay, wireless energy transfer proof of concept was actually given by some MIT based company, and we were thinking, can we do energy routing like this example that we have in this the right hand this one actually. So these, let's say one node or two nodes are trying to transfer energy to this field node, but it is far away. So that this efficiency of transfer is not good enough. So can we place an intermediate node, like in communications we do actually, energy relaying, like information relaying actually. So this is we visualize. Likewise, there could be another scenario that this node is trying to charge this node, and can there be intermediate relay node which can improve this process actually. So this can act as kind of a relay, whereas the direct communication is going on actually. So these were the motivations that we started with actually. Yeah. So some of the things that we were visualizing in that direction, this is that there could be, let's say, field deployed nodes, and there could be, let's say, a terrestrial vehicle moving around, and then it is going to charge these nodes. For example, this vehicle has there is a road. The node that is placed is little bit away from the roadside, so potentially I may not have direct capability of transferring energy, or let's say in this scenario actually. So I transfer this energy to this node, and this node in turn transfers energy to this node, and so on. Likewise, there could be another visualization here. A drone is flying around, and then it is going to charge the nodes, the ground nodes which are deployed for collecting this ground information actually. So again, so as I mentioned, in this case, although we are aware of this constraint of minus 20 dBm, minus 30 dBm power level that is required for energy sufficient charging, so drone can possibly hover and lower itself down to that close range, and this can be made doable actually. And also one can think of beamforming, and by beamforming one can actually concentrate the energy to some extent, and then this could be possible. Okay, this is again a visualization, and we will show some experiments that we performed in that direction. So first thing that we did here is that we first wanted to do the proof of concept of wireless energy routing. So this node is a node that we are intending to charge, and we purposefully placed two other two nodes. Let's say consider one node here. Let's say this node. This node acts as a relay. It does not have any external energy supply. It is actually positioned in a way that it is harvesting the wasteful electromagnetic radiation, and that wasteful radiation is used for charging its own supercapacitor, and then supercapacitor, whenever supercapacitor level is above certain threshold, it triggers its own receiver, its own transmitter to transfer in this direction actually. Likewise, there could be another node, etc. That is what we experimentally constructed, and then showed that this is actually doing well in terms of energy transfer. So so our initial thought process was that to demonstrate that this energy routing. So this node is, remember, this node is not having external energy source. That means overall energy efficiency is improved by placing this node and this node. For the time being, let's set aside the extra hardware cost. Okay. We had some results showing that we can gain, in fact, by simply by going by that, doing that, we could gain about 20%, 30% efficiency, the enhanced efficiency, meaning that if this node directly transfers energy to this node, the amount of time it takes is much larger compared to if I place these nodes as kind of helper actually. Okay. This experiment was very, very challenging. In fact, we struggled possibly 3-4 years to do that. 2008 we started, 2012 we got some results and we started generating. So this also we extended to 3-hop routing. Now what we gathered is that, coming to this, what we found is that, so when I place an intermediate node, going back to this slide, these intermediate nodes, what is the optimum position? Again, I am coming from, let's say, in information routing perspective, okay, communication relaying perspective. If I talk about communication relay, I will place this intermediate node kind of midway. It is let's say equal distance from this source and equidistant from this thing, kind of a let's say isosceles triangle, right? But our result shows that this is giving me worse performance. In fact, these 3 plots show that the case C, case B is that when the node is positions exactly at the kind of a symmetrically. This shows the energy gain, that the voltage level increase at the supercapacitor is slowest compared to other 2 cases. What are the other 2 cases? Other 2 cases are, case A is where the relay node is placed close to the receiver, and case B is relay node is placed close to the transmitter. So there are some intuitions, but intuition is that the intermediate position, equidistant position, is neither good for energy collection nor good for energy retransmission to the other node actually. So again so the question then is that, if I am given a set of parameters, if I am given the set of transmission parameters, antenna dimensions, etc., can I compute what is the optimal position of the relay node which will give me maximum power energy transfer gain actually. So that became a theoretical problem we extracted. So for the students, the motivation here is that this we started as an experimental first proof of concept that energy transfer, energy routing is practically feasible, and in the previous slide I showed that we are gaining something, but we found that there is an optimization requirement. How do I find the node placement optimally so that I gain from energy transfer, maximum possible gain is achieved actually. So that led to this the theoretical problem definition actually. So one thing that we see here, the sawtooth nature is interesting. Basically, as I mentioned, the intermediate node doesn't have any external energy source. So what it is doing is that it is intermediate node is collecting energy for some time, and momentarily it is trying to discharge, radiating to the other node, to the target node, and whenever it radiates, the discharge level goes below certain threshold, again it goes to charging mode actually. So that we had to program the relay node accordingly to make that happen actually. So this is why this sawtooth, basically it is growing slowly, but it is sometimes it is reducing actually. That is because it is whenever it is increasing means the energy supply is coming from the direct path as well as the routed path actually. And whenever it drops, that means that routed paths are currently stopped and the relay path, the direct path is available actually. So that led to one theoretical problem definition, that how do I find out what is the optimal position of the relay node. So we had to again to cut short because there are dense slides I have to discuss. So what we wanted is that we wanted to approximate the problem. Again, as I mentioned, we extracted a theoretical problem out of this experimentation. So we need to find, we called a box approximation. Actually, this optimal position of the relay node is coming to be kind of elliptical. So we created a box, rather box approximation. And then now the question is that within this rectangle, what is the optimal position of the relay node that gives me maximum gain for these source and destination with certain antenna parameters and the distance, etc. So these source and destination distance is fixed and their antenna parameters are given. These antenna parameters are given. Now I need to find the optimal position. So again I'll skip through some of the details here. So that led to first optimization formulation, that this is kind of a two-dimensional positioning actually. So I am looking for maximizing these energy transfer gain, and I need to find out what is the optimal position of these optimal x coordinate and y coordinate. Okay. Now as we were doing, so this we got something, I'll skip through. As we were doing, we also found out another interesting observation. It is intuitive, but we need to actually observation is that, see, if I let the relay node remain as close as possible on this line, I expect that this is going to do better, because the distance from, as the radiation distance increases, the inefficiency increases actually. So if the relay node is placed on this axis, this should be doing the best, but it is not necessarily the case because of something called constructive and destructive interference actually. So this next slide is actually talking about that. So what happens is that as I move this relay, as I move the relay position from one point to another point, let's say just on the linear axis here, it is not monotonically increasing the gain. Instead, it is sometimes decreasing also. Okay, so that is to do with the fact, this is what is observed here actually. So some positions are actually constructive interference positions, and some positions are destructive interference positions actually, because these so here at the receiver, what is happening is that signals are coming from two directions, and these two signals have to be so called how does interference happens. So we need to, as we know from basic principle, phase coherence, right? This is one term that we are mostly aware of actually. So phase coherence, whenever it is happening, we are calling constructive interference, and other is the destructive interference. So as a result, not all positions in that grid is optimal. Likewise, not all positions on the x-axis is also optimal actually. On this thing. Yeah, on these axes actually, x-axis. So so now what we in the problem formulation 2, what we are considering is that so instead of letting this node choose the optimal position in the grid without thinking of constructive and destructive interference, or rather can we position these along the x-axis and consider that we will rather have constructive interference, we will make sure the constructive interference happens, then what is the optimal position? So that led to this problem formulation, meaning that I am only going to move along the x-axis. So that led to another problem, is that how do I ensure constructive interference when it is otherwise going to be destructive? So this is called beamforming, and in this case, this beamforming problem, I will go back to my original diagram here. This beamforming problem is something called distributed beamforming. Why? Because this is my source. This source has its own internal oscillators, etc., and this has its own oscillator, and as a result, these two beams that are coming this direction and this direction, these need to be coherently added here, and additional challenge is that it is not only path difference but also the phase decoherence of the crystal oscillators, because these are independent crystal oscillators actually. So this that led to the problem of distributed beamforming actually, which is again from the communication theory perspective, we are aware of MIMO. So we normally talk about the beamforming, but this is actually centralized beamforming, meaning the same clock is being fed to different antenna elements, whereas in this case, this you can treat this as 3 antenna elements, one antenna element, another antenna element and another antenna element, but these are fed by independent clocks. So that led to the additional challenge of distributed beamforming. So, so here theoretically we considered that if somehow beamforming could be achieved, then what is the optimal position? So I will skip several results. There are several other constraints actually to be we had to account for. One is that energy harvesting efficiency is actually very nonlinear. So that also had to be accounted for. So what is happening is that, as you can see in the case of 1D meaning that I am moving only along x-axis, still this is a kind of oscillatory. It is not a pure convex problem actually. Okay, so that that led to optimization. On the other hand, if I had 2D optimization is very non-convex actually, as you can see. So optimal positions are have to be found. Okay, so because we did experimental study, we started with experimental study. So we also actually trying to we are finding out certain counterintuitive observations actually. So what was happening? This was our starting experiment. I'll go to another figure and I'll come back actually. So this is like experimental setup. Later on we moved to anechoic chamber and did something, but so this can be formulated as I have a source, I have a transmitter, a receiver, and then there is no relay as such. And what we are trying to do is I have a transmitter, I have a receiver, and then as I am moving the receiver close to the transmitter, I am expecting that my energy gain should be increased only. But what we are finding experimentally is that energy gain is not monotonically increasing, but again this is happening sometimes decreasing also. So although I am just slowly reducing the distance, at smaller distance I am expecting that my energy should be higher, but it is actually not happening. Sometimes it is lower also. So that led to find out what is going on, and we anticipated that this has to do with possibly the reflection from the ground actually. So tabletop reflection is causing kind of a interference, and that interfering signal is causing me this thing, destructive interference sometimes, and as a result, although my distance is reduced, I am gaining power lesser than larger distance actually. So that led to, again, those who have been doing wireless communication, we are aware of the Wallace-Rappaport's two-ray model. So we actually wanted to look back at that problem actually. So two-ray model, if we see that it has been actually approximated, and we eventually say that by two-ray model my path loss factor goes from 2 to 4 actually. Okay, but there are lots of approximations made, and these approximations do not hold true in our scenario because we are talking about much shorter distance. As a result, this angle approximation is not possible, and most importantly, it actually ignored the effect of the antenna polarization actually. So we actually wanted to redo this study, that Rappaport study, in our context, and then that led to fantastic some interesting results actually. So I'll skip through some of the analysis. So first we wanted to prove to ourselves that this as I reduce the distance, monotonically power increase is not happening is indeed because of the reflection. So we went to anechoic chamber, and then we found out this is actually giving us path loss factor, which is Friis formula based path loss factor 2. Whereas if I place a reflector of different type, let's say cardboard or copper foil, etc., we are getting something else. And that then the question here is that how do I find out, let's say in this case my transmitter and receiver distance is fixed, now I am changing the height only. In fact, in our experimental setup, only possibility was changing height actually, because this was for antenna design. So by changing height, we are getting the similar effect of constructive and destructive interference, and we demonstrated that there are some optimal positioning could be possible. So one byproduct observation here is the effect of polarization actually. So as we can see here, that as we go from vertical polarization to horizontal polarization, meaning that if the antenna elements are like this, vertically polarized, or like this, horizontally polarized, the effect of reflection is very different. So these two scenarios actually. For the same height, as I change the height for the same distance, in one case vertical polarization the behavior is this, whereas horizontal polarization is behavior is very fluctuating actually. So this is one again intriguing to us, and we needed to look at what is the reason actually. So how to optimize in terms of antenna polarization for maximizing the gain of energy transfer actually. So that problem we set aside for later purpose. We will come back to that actually. So this is that led to finding out what is the optimal. So I'll skip through some details here. Basically what we are saying is that even for a simple transmitter to receiver where there is no relay, I need to position optimally to achieve the maximal power transfer gain. And if I do that, basically my so why am I interested in this computation is because I need to actually calculate how much time I require to charge a node actually. If I use Friis formula, my calculation is very incorrect actually. So we need to actually account for these reflection and so on. So this constructive and destructive interference that is happening so far, we term this as passive beamforming, because there is a source which is transmitting, the other beam that is coming is actually because of reflection, it is actually passive. So passive beamforming. So here we are talking about how to optimize in terms of passive beamforming actually, right? So in terms of distance is what we played with in one dimension actually. So there is another byproduct here we intended to study here is that normally, so if I do this experiment, let's say in field, so there what happens is that I have potential multipaths, right? So it is not only one reflected path, maybe because of this random nature there could be multiple scattering components that are coming to the receiver actually. So our question was that if I do this experiment, or if I propose this wireless energy transfer in field scenario, what should be my path loss factor, and also how do I model this channel actually, wireless channel model for wireless energy transfer. Okay, so this intuitively because my energy the line of sight is pretty strong, we could actually model as Ricean channel. But the question is, what is the K factor I should have actually? K factor, normally if you look at again classical books like Rappaport or Goldsmith, K factor typically considered to be 10 dB to 30 dB. Okay, here we wanted to actually study for ourselves what is the K factor to be considered actually. So that is what is the some experimental study again we did, and I'll quickly show that for different cases, garden environment, roadside, factory floor we actually kind of emulated on the corridor, and the roadside is roadside and so on, and we see that vertical polarization and horizontal polarization have kind of quite different, quite significantly large K factor. So this result is actually useful for our further study of wireless energy transfer, instead of choosing some K factor which is actually quite untrue from actual reality. As you can see, this is on the order of 60, 50 dB, etc. Okay, so I could quickly move on. Okay, so now comes to the other aspect, that now that I have a if I have a way to control this beam. So far I have talked about beamforming, which is passive beamforming. Now question is, can I create this the beamforming which is controllable actually? Okay, so theoretically what we have is that if I have n sources, I will go to this diagram and then move back. So if I have n sources, n wireless, time is up, maybe 5 minutes, 2 minutes, sorry. So if I have n sources, and each of them, let's say individually, is contributing power P to the receiver, and if these n sources are allowed to transmit together, what is the total power that this receiver will get? If these n sources are uncoordinated altogether, then the total power can be n times P. Whereas if these n sources are transmitting coordinatedly, meaning that at the receiver I am doing beamforming, this power received could be n square p. So if they are uncoordinated, I am gaining linearly, whereas if they are coordinated, I am gaining square law actually, which is tremendous, right? So basically, if I am able to do the beamforming, I am getting n square type this thing. So how do I achieve that? So this is a quite intricate problem actually. So there have been some studies sporadically distributed beamforming, but what we figured out in our scenario, there is no feedback possible. People have actually talked about feedback based correction of phase of the transmitter, etc. So we came up with the consideration that can the phase be estimated at the receiver itself, and then receiver will do the beamforming, meaning that the sources are transmitting as they are, and then whatever phase misalignment is happening at the receiver actually, right? So this is the we call active beamforming, and we call distributed beamforming because this is these sources are independent actually, and that led to some further protocol details I'll skip through, and some experimentally also we figured out that how this beamforming can be achieved. So basically, so far what we have been talking about is that phase alignment in the beamforming actually. Okay, as I mentioned here, as you can see, these are actually vertically polarized, and we are talking about only phase alignment actually. Now, question is that consider that I am interested in wireless energy transfer in, let's say, Indian context where, let's say, very polluted environment actually. So what happens is that polluted air actually. So when I am transmitting vertically polarized signal, although I don't have any other reflector or anything, let's say forget about for now, my receive polarization is not necessarily vertical. It is actually getting, normally if we talk about free space, we normally consider that the polarization does not change actually. Here on the other hand, polarization actually gets deoriented because of this scattering in the particulate matters, because of the particulate matters actually. So how do I account for that is the question that we looked at. So there is another intermediate very nice observations here is that if I have to do phase correction from multiple sources, how do I optimize that actually? So we actually exploited the channel phase characteristics, which is very unique compared to what we consider uniformly distributed phase distribution, which is not. This is symmetric. If the scattering environment is symmetric, this is the phase distribution, and so on. Yeah. I'm closing. Okay, so this shows tremendous amount of gain and so on. Okay, there are some theoretical analysis I am skipping through. So basically this was to motivate that actually this can be actually theoretically proven how the beamforming can be achieved and how the phase characteristics can be exploited actually. So this is we moved to optical beamforming, and there we specifically targeted what is the effect of polarization actually. If the phase coherence is done, but if the polarization is not aligned properly, then this is significantly degrading in terms of overall gain that is achievable. So we came up with some construction. I'll skip through. Finally, let me close this concluding slide here. There are multiple advantages, as I mentioned, wireless energy transfer, and one of these things that is attracting our attention is that this could be used for distributed energy weapon, for example actually. So I can have very low power sources which are individually cannot do any harm to a target, but these low power sources can be coherently transmitting the energy to the receiver can be destroyed actually, meaning that it can be created as a distributed energy weapon where the energy of the individual sources could be very low actually. Why this is important? Because energy increases the cost non-linearly actually. Okay, so that is about my presentation about the technical part, and couple of slides that I have been asked to put regarding these recommendations actually, if you allow me. Okay, so
not here.
Okay.
Thank you very much. Thanks a lot. Maybe we have time for one or two quick questions if you have. I just have one quick question. So when you say energy routing, so you transfer RF energy, right? Then you convert into DC and then convert to RF, or how you do this routing?
So typically yes, the initial demonstration that we did is that actually. So I have RF. And then I am converting to DC, storing on the supercapacitor, and then supercapacitor is now charging the transmitter.
So you use some rectifier in this case?
Yeah, we used this. We use this. This is the energy harvester module we used altogether actually.
You use a module.
Yeah, but there is another way also. In fact, we have a patent on that. is that we are actually not converting to DC at all actually. We are kind of using active antenna principle there. So we are just doing phase correction actually. So there is this crystal free routing in that case.
What frequency you have used for this?
So that part was 2.4 gigahertz, and the experimental part were done in 915 megahertz, because that is the hardware that we have actually.
Okay, thank you very much.
Okay, so these slides I may not be able to present because I will be leaving today, but yeah, this has been shared actually. I will email. So this slide and this slide, some suggestions actually. Yeah. Okay, all right, thank you.
So thank you very much. And before I go to next talk, I will request the speaker to please limit yourself to half an hour, because we have limited time. We already in late. So our next speaker is Professor Ajay Agrawal from IIT Jodhpur. He is professor there in Department of Electrical Engineering. He worked at many places, like, he's welcome. He worked also at ex-CEO Innovation. He worked a lot of foundations. He also had leadership role at IIT Sayal Siri, Chandigarh. He is a fellow of this. He is a fellow of IIT, IEI, SSI. He got number of awards like Excellence in Research Awards and AI Data Scientist, National Technology Award. His biography features in who is who in the world and who is who in Asia. He's going to talk about AI-enabled nanosensors for biomedical or biomarker detection. Thank you very much. So, please go ahead.
Thank you very much for the introduction and for the invite. This talk is interdisciplinary talk, and this session is also interdisciplinary, so I think I'll do some justice to this session. As the topic suggests, AI-enabled nanosensors for trace-level biomarker. So there are few keywords here. The nanosensors, it's a hot topic for last decade or more than that, last 2 decades. The challenge has been how to use this material for different applications, which is the real applications. And now I'll be focusing on some of the applications for trace level molecular detection using these type of sensors, and how AI can help that one. So importance of these nanosensors, I'll show some examples what we are doing. I'll not be able to show some latest example because of some proprietary issues, but that will give a good idea what these can do. The other thing is how AI can help us, because we are getting very low signals from these nanosensors, and when we are looking for trace level, these are really very bleak signals, electrical signals. So how AI can help that one? I'll try to show that one. This part we understand that this slide is mainly for the students. They understand this nanotechnologies and nanomaterial are important for various sensor application because they are sensitive. They make the sensors ultimately the sensitive sensors, and new different ways of signal transduction technologies in biosensors possible because of this material. When we talk of different way of signal detection, say typically biosensors, when we say that traditionally biomolecules are being detected using antibody antigen reactions, but using these nanosensors we are detecting in very different ways. So that is what the electronics is doing for these biosensors, and being some micro dimensions, we are able to make some nanosensors which are simple, which are rapid also in detection their results, and many in vivo testing can be done using these type of sensors. And since the sensor is small, electronics is today possible in a very smaller size also. A lot of portable systems are possible which can do a good job. How AI can help? Typically increasing the possibility of finding the accurate biomarkers. So all the diseases are connected to some biomarkers, so that's why it's interdisciplinary. We depend on a lot of biochemists also and the medical doctors also to identify the biomarkers which are signatures of different conditions or diseases. So we are able to detect these biomarkers accurately, and which leads to the accuracy of the patient outcome. That means non-specific medicines are not given. We are not giving the general antibiotics with these type of accurate detection of the. I'll discuss on some of the examples how this non-specificity is taken care of. This can avoid the immunity compromise in neonatal. So one of such example, we are working with the neonatal department of AIMS Jodhpur, where say a baby is born and if he has an infection, like sepsis is one of the common infections in hospitals, in neonates. So if doctor knows what kind of infection it is a bacterial infection, fungal infection first. If it is a bacterial, it is a gram positive, gram negative. These are the two basic classes. Then he can give a specific medicine. Otherwise, he has to give a general antibiotic, and the immunity of the baby is compromised from the very beginning. So that's how it is helping us. And definitely, early diagnosis is possible. Early means when the markers are in very low concentration. So our normal diagnostic techniques are not able to detect at those levels. So we are able to detect early and rapid both. So using these sensors. So we are focusing on point of care solution, early diagnostics using this one. AI/ML we are using for accurate decisions, and low cost disposable devices. Exact disease markers are identified, and personalized and accurate treatment is possible. Why I am saying personalized? Because it is not a common medicine or general medicine given. If you know what kind of infection is there or what kind of disease is there, you can give a personalized medication to a person. And these technologies we are working on are all scalable. It's not just one of its kind and the next time you repeat and it will not work. And we are also focusing on number of non-invasive diagnostics. That means we are not even using the blood. So we are looking for other bio samples like saliva, sweat, which has a lot of markers, and it is a hot topic worldwide. And why nanosensors can work here? Because the concentration of the markers in these samples is much lower, and the challenges are there are a lot of other interfering molecules there, and how we can take care of those signals. So that's why AI with these nanosensors can take care of some of the samples. I'll touch upon some of these examples also. So when we come to a biochemical detection system, a biodetection system, typically if you see on this table, we are looking for some cells, tissues. It has some molecules or the markers. We are looking for the blood as a sample, the urine, saliva. These are some of the common samples. These are similar to our food. When we are going for the food testing, we are again looking for some molecules there. And same for the environmental testing. So we are looking for some molecular analysis. So the work is focused on various molecular analysis. There may be some cells also, like microbes if we are looking for. Microbes are single cellular units, but in those cells also we are looking for some signature markers which are telling the presence of these cell or microbes. Here in this slide, if you see the transducers, if you are seeing the second one, the transducers are here. These are different kind of symbolic representation of different kind of devices. Say FET type of devices, a number of FET type of nanowire type of devices. That means you have a channel which is a nano-dimensional, it's very sensitive to a very small charge, and these are good for various charge-based molecules detection. And almost 90% of the molecules have some charges. So if I can attach these molecules specifically on my surface,
I'll get a change. I'll show you some examples also, but this change is very small. We'll see this side later on, but how to specifically attach these molecules of interest on this one, I need these bioreceptors. So there are receptors, and biochemists are well averse by this type of knowledge, what molecule we want to attach, and accordingly we can design bioreceptors which are placed on these sensors, and very specifically we can bind the molecule of interest, and corresponding electrical changes can be recorded. Similarly, nanoparticle based or electrode based, there are different kind of sensors. So this is what my expertise is. I'm making these type of sensors here. I do work with various biochemists for biomarker identification, their bioreceptor identification, and next is when we are looking for a small amount of charges here, or a small amount of molecules detection, the changes are also very small. So we need a very good signal amplifier also. So that's how a lot of work for the circuit engineers and design engineers. And then the signal need to be processed. So processing of the signal. Here comes the AI also. How we process with respect to the background noise, and we are using various AI experts with us so that we can process the signal and meaningful output comes. And then output could be in terms of some graphs like in ECG, or it could be yes, no, red and green type of signal, or there could be a quantification of some numbers like in glucometers. So all those outputs would be there depending on the need. I'll take some examples and with how these sensors are working. This is one platform device, nano structured array of for SERS. SERS is surface enhanced Raman spectroscopy. Raman spectroscopy, as we understand, is a standard technique for identification of different molecules. It's based on different the vibrational frequency of different functional groups. So that's a very standard technique. But Raman spectroscopy needs a lot of molecules, because the Raman signal is very weak. It's a very weak signal. So, and I am looking for a trace level molecule detection. So it's not possible at all. So what we are doing this enhancement of the signal, of the Raman signal, using surface enhanced. So that is called surface enhanced Raman spectroscopy. This technique is also well established. The challenge is how to make a good substrate. This is one of the pictures here which is showing. So what happens in surface enhanced Raman spectroscopy, you need to have this schematic is showing a nano gap. There has to be a nano gap, and if a molecule comes inside, the Raman signature of that single molecule can enhance 1 million to 1 billion times. So that electromagnetic magnification happens of that vibrational frequency in the vicinity of these walls of a noble metal only. So that's very good. So if I can bring my molecule here, if I have few molecules, I bring it here, it can give a signature of something like a 1 million or 1 billion molecules. But how to bring a molecule? That's a challenge. I have a sample which has only few molecules. I cannot bring specifically a molecule in this space. So what we have done otherwise, we make large number of such gaps, the nano gaps, in a very small area, and all should work in a almost similar way. All should be able to magnify that signal. So that's what you are seeing this image. You have large number of these nano gaps, and each gap is able to amplify. So if anywhere the molecule of our interest is sitting, the signature will enhance. And typically when we do Raman spectroscopy, we scan some area which is in say hundreds of micron, and if any molecule sits in that micron area, few hundred micron by few hundred micron, you can get a signal. And this gives us a huge application area, trace level detection of biological warfare, biomarkers, explosives. So applications are limitless here. This picture what I am showing is how to make a substrate which is very uniform. So we have taken say at 20 different places the spectra of a molecule, and what we are taking here, see these are the intensity of different peaks corresponding to the functional group, and if you plot them, they are within variation of 1% variation of the intensity. So intensity indicates when I am taking a spectra, one spectra from one point, if that molecule is sits there, is there amplification happening there? So this is what we are seeing. So this is quite reproducible. Something reproducibility was tested on a big substrate also. Here if you see on the left hand side, this is 1.5 mm by 0.5 mm substrate, and one of the again a test molecule rhodamine B, very low concentration 10 micromolar we have taken, and this particular peak, if you plot that peak, everywhere you are seeing the intensity of that peak is more than 1000 shots, the counts. So this indicates everywhere we are able to amplify. So we have done a mapping of this entire substrate using this Raman spectroscopy, and so substrates are giving. So it's a very uniform amplification at different places. So why I am showing this one? So the major challenge for the search-based applications is your substrate very uniform, and at every point are you able to amplify your signal? And there are different ways we are making in different ways. This is another chemical ways. I am just showing some pictures. You can deposit some nanoparticles, and these could be useful for enhancing the signal of Raman. Next I will come to why AI is important. I am showing one picture here. This work we started about 7-8 years back in my previous institution with the help of Tata Memorial, and we visited them, and we were told that breast cancer, a doctor wants to know on the bedside when he is doing operation, is the sample what they are removing is clean or having still a breast cancer marker. So they told us there are 3 markers there. So they are abbreviated as ER, PR and HER2. So these are the 3 markers, and they wanted us to check using this technique if we can identify these markers. So this is a mixed signal of all 3 markers together. So it is very complicated output. Humanly it is very difficult. So here comes the AI's role, and we could not take it further because of some other administrative reasons, but this type of applications we can focus further, and there are some new techniques now how the doctors are doing, but this is one of the technique. I'll take up some other examples in subsequent slides where we have used AI to identify the. This is some recent work we did. We wanted to check at the early stage of the COVID, when the COVID came in 20. So this project we started, can we detect COVID from the saliva instead of tissue? Because if it is in the tissue, it is in our saliva also, and we should be able to. So this is what I am showing is right hand side. What you are seeing is a spectra of normal people subject saliva. So 9 subjects were taken, so they are imposing. So this is a spectra, so almost similar. Some peaks are there which are outliers or something coming from their saliva. But if you take these 9 samples, this work we did with a collaborator from Trivandrum. In a hospital we have collected saliva of 9 patients, and you can see that spectra is very different. So visually it is there, but we can distinguish here. But is it COVID-2, COVID-1 or MERS? There are 3 type of COVID viruses. So we have taken all the 3, and here you can see this COVID-1 is red, then COVID-2 and this MERS. These spectra are also different. We have done a detailed analysis. I am not putting the entire result here. This is all published work. Very detailed work is published, and just PC analysis shows these spectra are very different. They are very much differently placed, and using different analysis, we have confusion matrix also suggests that they are all three very different, and with a proper AI algorithm teaching a mixed sample, any sample can be used to detect using the saliva, and this is almost instantaneous, not much of sample processing required. And this table shows some of the peaks we have found. Another example I am showing about markers or some pesticides on our food. Many times today we are not taking the fruits without peeling because we are worried that pesticides must have been or might have been used in the farms, and those pesticides might be on the fruit skin, apple basically, or many other fruits. So we have done this work on the apple. We have tested the apple first, which was quite clean, but we put a very different concentration of some pesticides in the water, and then we have taken that water and tested. And these are the testing done for very low concentration to a bit high, and these are the peaks. And we can quantify what kind of the pesticide is available on the. So what we have done, we have taken these apples, we have just sprayed some very low concentration of these pesticides, kept it in the environment for some time, dried and used, and later on we just put it in the water, and we have taken those water to test out if the signatures are there. So those are visible there. So there could be a way to do different fruits, but it can tell us if any pesticide or unwanted chemicals are being used, and that can be used for the quality purpose. This work, again very interesting work, this came to us from the Ayurvedic application point of view. Ayurveda uses honey as one of the carrier for the medicine. So we were told, and the honey industry in India also is a very big industry. It's a 3,000 crores business, and a huge amount is exported. And we were told that testing is done in some German lab, and it takes a lot of time for the honey to be qualified for the export purpose. So we have started this one, and the challenge is, if the honey is coming from a farm where the pesticides or antibiotics are used, that goes in traces in the honey. So organic honey and the normal honey, those are very different. So we could find out some markers here, and this is the technique we have done. And again, this work is, the bottom graph here shows the top circle is indicating the signature of organic honey, which has some flavoids also, the signature of the flavoids, which are the actual honey. So this is certified honey we have taken from German lab. The other signatures are, three circles are for three different honey from the market, popular brands. So all are very different. So that shows the honey doesn't mean always honey. And these are the spectral analysis what we have done for various pesticides which are normally used for bee farming purpose and other, and we could identify, and we are able to separate. This work is also we have published. I'll come to another. So this technique we are using for some of the applications for early diagnostics and rapid diagnostics with the AIMS Jodhpur as our partner. So one is the sepsis I have already told. The other one is fungal infection in the ICU setups. And fungal infection is a major challenge in ICU because it takes 3 to 5 days minimum to identify if a patient is really infected by a fungal infection. And they cannot give medicine without a confirmatory test. And in ICU, we understand many times the patients are critically ill. And we are targeting to do it within an hour or so using this technique. So we are working on the sample processing protocol at this moment, and we are working on another very first time we are attempting on the trauma cases when there is a head injury or in the head operation cases, when there is a lot of blood loss or so if the CSF is leaking from the brain cavity, because that CSF, the cyber CSF is the liquid where the brain is protected and which is colorless also, and it leaks many times and it is dangerous. And today the test is very costly and it is very time consuming. That is what even many of the AIIMS in India are not having such a test, and we are attempting on that one using this type of technique. So initial results based on some of the markers related to these are very interesting, and we are in the process of IP. So that's why I am not able to share those results here. The other platform which is of interest to many is nanowire based, or so the capability here, the previous technique was also a multiplex technique. That means in a single test one can detect multiple biomarkers. Here the nanowire based, this is the nanowires we have realized where different kind of wires can be modified for different kind of biomarkers, and in a single test different markers can be. So these are the some pictures of different kind of nanowire. This work I did in Singapore and not in India. So this is my old work, but this has a huge capability to detect multiple markers in a sample, and this is a typical chip we designed for a company from Australia, and this is actual chip, and we could do a lot of testing, and it's a tabletop system we developed, and you can do this conclavation also for different set of wires which are about 200 microns. So this type of technology do exist, and for data processing we need dedicated chip and system. I'll skip some of the examples here which we have demonstrated. This could be used for drug discovery also. So you have a live cells and you have nanowires, and when you give different drugs and how they respond in a real form, that is possible to detect using this type of. This is something from the tissue. So this is the heart, the live heart we have taken from the mice, and this ECG signal here is from the surface, and this is by the microprobe. So that means these sensors are quite sensitive, and very small electrical signals from the surface or sensitive parts can be detected, and this could be useful for many diagnosis purposes. Non-invasive, I will touch upon quickly. As I mentioned, saliva is one of the samples we are using, and I am not going into the details of this slide, but we are working on various metal organic frameworks, and metal and inorganic compounds are mixed together, and we are making some nano surface or nano structure, and we are putting these on electrochemical electrodes, and these are giving very fantastic results in the sensitivity point of view and the repeatability point of view. These are some of the images here, and these are some results. And again, we are in the patenting, so I am not discussing much here, but we are able to detect very low concentration. We are able to distinguish some of the signals with the other interfering molecules also using this type of technique. And yes, we are using AI, and a lot of pattern recognition part is being done here. So the objective here is, can we detect blood glucose equivalent using saliva? So no pricking is required, and something similar we are attempting. So this is our last example here. Breath is also a non-invasive sample, and which is very much useful for diagnosing many things. What we are attempting is asthma. So asthma has NO gas in our breath, and if you see, the healthy person has the NO level less than 25 ppb. It's a very small quantity, and if it is more than 50 ppb, it is a asthmatic case. So detecting in such a low concentration in a sample where there are so many other interfering, that's a major challenge. And these are two other molecules also, IL-4 and IL-13, which are the molecular markers which are associated with asthma. So we are looking for twin sensors here. One is a gas sensor based on NO. This work we have established. So here is the publication. Recently it has come, and using various AI algorithms, we have found that some of those are very well working, and we are able to distinguish such a low signal NO in a sample. The other part is in progress at this moment, and which is based on Raman spectroscopy. So first is a gas sensor, other one. So these are the two techniques we are working on. So these are already realized, and I'm just showing one figure here. But if somebody is interested, that paper can be referred, and it has a very detailed work on this one. The other is Raman based, so this work is in progress at this moment. Thank you. In conclusion, I'll say the nanotechnologies are offering huge opportunities and challenges also for healthcare applications. And to realize such a digital point of care or early diagnostic solution, various engineering sciences have a role to play. And if you see here, the sensor design is one, and then realization using micro nanotechnologies. So now in India, we have a lot of facilities where these can be realized, and they can be realized in a very good number so that these applications can be done. Electronic circuits, signal processing is definitely a very important aspect, and it has a big role to play to realize the final product. And for data analytics and AI, definitely without that it's not possible using the type of sensor. And yes, overall the final is the instrumentation. We have to realize these instruments. So all these knowledge are required. They do exist in our all systems, in all our institutions. They have to work together, and that's what I am also attempting in our effort. I'll say one last point here, that when we are looking for a device or what kind of sensor, we have to be very selective about what kind of marker we are looking for, and what kind of signature we want to capture, and what kind of concentration we are looking for, because all the sensors are not of the same capability, or all do not have the same way of detection. So we need to focus on these aspects. Finally, this is my current team, research scholars working with me. I also acknowledge my collaborators and the funding agencies who are supporting this work. Thank you very much.
Thank you very much. We have time for one or two quick questions if we have. Yes, sir.
So one of the things, first of all, thank you for your nice lecture. One of the things that is coming to my mind is we are detecting some out of these multiple parameters, parameters. Particularly, I find that sometimes it so happens that presence of one blood parameter or any biofluid parameter suppresses the detection of other biofluid parameters. So how are you handling such kind of, for example, I'm giving a small example, particularly if you want to detect allocerums in presence of this aberrant polytropic form of the control lateral site of the abnormal plant, you will always find it. How do you really handle this kind of things?
Yes, so sample processing is one very key thing. So many times you are right. Some of the markers, we know that these markers are there, but many times these markers are hidden or masked by some other layers. So if I am talking of microbes, I am working on most of the microbes here, and the markers are many times hidden and they are masked by some other. So you have to break it. So there is a chemical process to break that wall, or you have to lyse that cell and look for some other markers. So it's a chemical processing basically, and some signature has to come. Otherwise, if your signature is not picked by your sensor, it's useless. So sample processing,
There is some auto-license involved.
different. It's all customized for all different applications.
Yeah. So I have one small question. So if you have SORS setup, is it like time consuming, or it is how long it takes to analyze?
Analysis takes hardly a minute or so.
Okay.
So actually the search chip we are making, and these chips are there. You have to just put a sample and just scan it, and immediately you get that. So if the algorithm is made, the signals are coming, and that analysis is done in real time. We are getting
So
that.
you don't have to go to a typical Raman spectrometer.
It's a Raman spectrometer. So analysis done on the Raman spectrometer. I didn't mention we are now making our own spectrometer for a specific wavelengths or this wave numbers also, which is not the generic one. So that will reduce the cost also, and we'll be looking for specific signals.
Those will be also portable kind
Portable systems.
So as of now, what's the cost of this system?
The cheapest one in the market are about 15-20 lakhs. One we have demonstrated sometime back when we were working together. It was within 2 lakhs. We demonstrated and it worked very well.
Thank you very much. So one announcement, we will give all the momentum at the end. Please wait all the speakers. Thank you very much. So we have the next speaker, Professor Siddharth Panda from our own institute at Kanpur. He's professor here, and also he is heading the our laboratory for this. Yeah, Center for Physical Electronics. He has been working on sensor for many years. He had developed a lot of prototypes. Also, he has given rise to industry. So, you are welcome.
is the toughest time to remain awake and listen to the lectures. But I hope it will be an interesting session being chaired by Professor Lakshmidhar Behra. He's currently director of IIT Mandi. He did his PhD from IIT Delhi and also did postdoctoral work in the University of German National Research Center for Information Technology at St. Augustine. And he has over that 28 years of experience as a researcher. And he's a fellow of INAE. He's also an associate editor for IEEE Transactions of Cyber SMC's IEEE Transactions SMC, Systems and Cybernetics. He's also a distinguished alumni of NIT Roorkela. Apart from that, he has made significant contribution in terms of working robotics with industry. I think other than theoretical contributions, I think that is something very, very important to note, that from an academic institutions, getting really industry engaged and involved this kind of robotics projects. So, Lakshmidhar, it's now over to you.
Thank you, sir. We have very interesting 3 talks in this. We have Professor Subhajit Roy Chaudhary, Professor Subir Shah, and Professor Prasanna Gandhi. Given that SRC has a risk here, so we will start with Professor Subir Shah. His talk will be on robotics and cobotics at the IHFC of IIT Delhi. Just to give a little introduction, Professor Saha is a very senior professor at IIT Delhi in Mechanical Engineering Department. He, in fact, is the principal investigator and project director for the iHub, one of the iHubs set up by DST at IIT Delhi on cobotics. So if you look at his contribution, he has been a visiting faculty and professor at IIT Madras, short-term researcher at McGill University, Canada, University of Verona, Italy. Professor Shah published a textbook on Introduction to Robotics, whose 3rd edition in 2024 has been published by McGraw-Hill. To aid the learning of robotics fun and effective, his robot analyzer software was commercialized in 2022. He also co-authored several specialized books published by Springer, for example, Vision-Based Identification and Force Control of Industrial Robots. Hayat, Shraddha Chaudhary, R.A. Badi, Uday, Sumantra Dattaray, and Santanu Chaudhary. Professor Shah was the founding treasurer of the Robotics Society in India, later vice president of the society. Presently, he is the president of Association of Machines and Mechanism. So we look forward a very interesting talk from Professor Shah.
Thank you, Lakshmidhar, and thank you, Shantanu and Nayani, for inviting me and giving this chance to share what we have been doing it at IHFC, the Technology Innovation Hub of IIT Delhi, which was incubated in 2020, soon after it has been approved by the DST under the National Mission on Interdisciplinary Cyber-Physical Systems. As a part of our presentation, I have already shared some recommendation which I presume will be discussed tomorrow. So that's our iconic building in the left-hand side, Convocation Hall, and the right-hand side is the new research park where our IHFC is located. So briefly to talk about me, other than the formal thing, I have basically considered myself having 2 kind of hats, which all starts with R. One is robotic computation based education and engineering, like for example, you can see these 2 mobile robots. The one in the center was tested by a company called PI Robotics, one of our robotics club member, who is doing big business of $7 million. His head office is in the US. And the left one, it's been tech transferred to a company in Pune, SB Robotics. but my theme here is how to impart education other than the formal ways of blackboard, whiteboard and all those things. It's a hands-on training, and in addition is a competition is a key theme actually, and that led 2008 a competition to commercial products, 2 of them. And the other one is actually related to the rural technologies. So these are the 2 technologies. The one at the bottom has already made a big news with 1 PhD thesis graduated already. If you go Mala Se Malamal in YouTube under Sansad TV, you will see 30 minutes video how we have impacted in a village in Jait in close to Mathura district. So coming back to the iHub Foundation for Robotics, I just mentioned, and as per the DST mandates, like all other hubs, whoever you hear today or tomorrow, they have all right-hand side the 4 mandates which are common to all of us. The research and development, which are to be TRL 4 and above, technology readiness level 4 and above, and then the startups funding. The investment, we call it investments, and then the education and training, and then the international collaboration. I'll have few slides and videos on each of those, which I'll show in detail. But some innovations we try to inbuilt as a part of all these activities, even though they are very common terminologies. Just to talk about R&D, research and development, we have clusters. About 40 projects into about 9, we call it grand projects. And good to see our Professor Behra here. He is actually heading 2 of the grand projects initially. Now he is having 1 because he has become a director now. So he is looking after the healthcare robotics, under which about 7-8 professors are working. The idea here is, in our country we are very good at our own level. But how can we be good when we are working together? So that was basically the essence. But I'll tell you, 5 years journey has been very rough for us actually. Slowly getting smoothened up. Some of these things are coming up. Tomorrow we have a meeting with another grand project coordinator with Ashish Datta, mechanical here. Anyway, so the journey is going on. So one Professor Junjunwala, after his retirement at Madras, so he has been looking after some Section 8 company with big funding around the world. So he is interested to see what we are doing and where he can pump in money. Just now I was talking to Abhishek here. So he has sent an email that can we discuss more about this to see what money can be brought in under nanorobotics. And another one is Industry 4.0. Startup funding, our first startup initiation was the Bot Lab Dynamics, who made the news in the not only in the country, but in the world. So 5,500 drones. Some of the good things are happening with the drones. Other than that, L&T has already, we have demonstrated a painting of the pillars. So we have 40 plus thing, and 2 of the companies wanted to return our investment, which is a good sign. One is in Articulus in Bangalore, and another is recently, I think, in IT Gandhinagar. So to be summarizing our activity, we are the Ola Uber of research, to put it that way actually. So we do not have any infrastructure because of 2 reasons. One, IIT Delhi has infrastructure issues, space issue, which has forced us to behave like Ola Uber research or Airbnb of hotels kind of thing, without having any resources ourselves. Still we own. So sometimes when people come to us and we have to see IHFC facility, they say you have to facility, go to the Tejpur University, go to Gandhinagar, go to Mandi, there you can see our facility. Coming to the third one, education and training. Many people think that we are doing a routine thing. Actually not. This is the biggest revenue earner for us at this moment. For the CIC board, we have introduced robotics and AI course for the 9, 10, 11, 12. And to have understanding that they have learned it. Last year we have conducted inter-school robotic competition with about 300 schools participating and culminating in Hyderabad, the final one. And all those things which are happening, we are collecting data that, how much inspiration it is having given to the students, the mentor, the teacher, school, because we would like to then make a contribution. It's good that I am here today. Maybe some of this input will provide to you, to INAE, as an education policy, future education policy. And now we are mapping with NEP that where it gets mapped. So all this research is going on at the back end. The front end, people do not see those things. It's happening. And so coming to the left hand side, so those are the 4 areas which mostly cover up all these things. Coming to last part, the international collaboration. Next week we are going to Vietnam. So their ambassador came to our IHFC once and they said, can we borrow the style of what are you doing it? Can some of these technologies be transferred? And I think for Professor Behra, I think Amit will be going with us to showcase his drone and EUV collaboration for pipeline gas inspection and stuff like that. Just to elaborate the word cobot, because to be very honest with you, when this approval came, it was not originally advertised by DST actually. So our theme was human-robot interaction, so they have identified the cobot word for us. Cobot means collaborative robots. Here you have one demo of one cobot made by KUKA Robotics, which was there in our laboratory. And this Arun, who is a faculty at IISM Nanmad now, when he was a PhD student, is actually teaching this robot by his hand, just like your parents will help you to write ABCDs kind of thing. No? So cobot, as I said, collaborative robotics, and the distinctions are shown in the left hand side and the right hand side of the bottom picture. Right hand side is typically the robot. Robots are put under the cage. Though you cannot enter it. As soon as you enter perceptor is in, it will stop. So it takes space, and you have to know the robot programming languages, and so there are huge investments there, other than any other inconveniences. On the left hand side, as you can see, the operator is inside. So it's a collaborative. It doesn't no harm. It will stop rather actually, if it touches and it goes about the threshold value. And for our country, it is more relevant because we have a good human resources with good intelligence actually. Why to replace unnecessarily, rather take the brain and machines precisions. So our engagement model is like hub is at the center. I think this is nothing very fancy, as we all know. So we take projects from here and there, and some of these initiatives actually. Now we have one Goa University projects, drone-based harvesting of coconut, and Marico Group from the CSR funding. So this is one joint project. And then earlier I was working with AIMS on teleoperated ultrasound robots, and it has been identified. Now it is going to Antarctica under Ministry of Earth Science Activity, NPCUR, National Center for Polar and Oceanography Research. The boy is already sitting in Goa. Maybe next week he will go to Antarctica, and inshallah everything goes all right by January, February. If everything is successful, the doctor from AIMS will be controlling that robot in Antarctica. And this will be executed by a startup company originated by a PhD student at IIT Delhi and another intern from IIT Guwahati. So here is 3-4 minutes corporate video. It will give the complete glimpse. We have recently celebrated our 5 years in September. So just please be patient to watch this 4 minutes video.
fast-evolving world of technology, where human and robotic intervention defines the future. IHFC, iHub Foundation for Robotics at IIT Delhi, is pioneering a revolution that has already begun, with IHFC having set up world-class center of excellences such as Biotechnology Park, Medical Robotics Center, and co-innovation centers which are bringing real-world solutions to
So this is the Botlab Dynamics video.
Foundation for Robotics at IIT Delhi is one of the 25 technology
The sound is okay, I think, just barely okay. So this is Arca Aerospace, just a video previous to it. So they took part in Operation Sindoor.
Today we have almost 40 startups and 25 early stage entrepreneurs. Some already successful and some very high promise.
So left hand side is the BLDC motor, IIT Delhi Professor Amit Jain, and one company in Ahmedabad.
Nurtures young minds from school
So this is for the International Telecommunication Union competition happening.
through college to their entrepreneurial journey.
So at the end of 5 years, I feel proud that IHFC has contributed not only to create world-class data systems, to build a world record. At the same time, we are on the path of productionizing one technology.
So this is one of our advanced level activity from Tezpur University. We have given to two companies for Tata LXI and Kalman Studio for the industrial design part.
Concept to the young minds of the country, especially at the secondary school stage.
The mission is poised to focus collaboration between government, academia, and research, thus bringing up a robust innovation ecosystem in the country.
So this is Articulus.
And how robotics can change people's lives. We have been enabling innovators, startups, ideas, to create a difference.
What we see is that this generation will be the one driving business rather than manufacture. We have also set up technical innovation centers, which have been set up in collaboration with some.
So this is a new initiative just happened last year. So to multiply IHFC effects, the 10 co-innovation center out of 32 applied for it.
As IHFC completes its 5 years, we feel it satisfying to note the achievements made by the hub under technology development, skill development, entrepreneurship development, and international collaboration.
So this is just the visit of that
IHFC now
embassy.
celebrates 5 years of its existence. We have come a long way. We've now created an ecosystem where we can support innovators, faculty members, researchers to take their journey forward in terms of robotics to make a difference in the Indian ecosystem. I wish we could make one of the best systems in the world, make our country, forefront of technology creations, and at the same time, Atmanirbhar Bharat, not only for Bharat, but also for the world.
So these are our presence of our research, startups and all others. This is the international collaboration. So I just mentioned our first collaboration started with NSF where DST wanted to have a joint proposal. So these are our the startup ecosystems just mentioned. So here I wanted to play some of the videos. So this is one of the project by one of our professor Sunil Jha.
Since last 17 years,
So he is working with a doctor at MMC for orthopedic plate bending machines.
IHFC is more about expressing the
Since the sound is low, so I am explaining. So typically the doctors after the MRI scan is done, so they have to bend the plates as per the requirement of the patient, so which takes a long time. So Sunil Jha has now created this machine which will take the CAD files and create the G codes, and it will then automatically bend.
So initially the need comes from the system anyone.
He is also heading our Industry 4.0 grand project, and he has this project also.
We give some data of bones, fractured bones of some patient who admitted at the INAE, and initially we followed an approach to 3D printer.
And so on the left hand side we have Professor Dhiman Malik of electrical department. So he has morning we have been hearing flexible printing, flexible electronics. So he has one such product which can be owned by anyone for the gate analysis and stuff like that. And right hand side is the one for which the industrial design is happening. So this is more than almost 15 years activity by the Professor Nayan Katoti. without funding, he has gone one step ahead, and he claims this is one of the fastest, reactionary prosthetic arm. And he has already done the field trial in Manipur, Assam, mostly Northeast belt.
Grasping by Enrich is tested with different objects. User's intention of grasping an object is collected as EMG signal generated from the muscle. The embedded controller processes the EMG signal and makes a decision for grasping.
And this technology effectively ready to go, except the look and other things. So we have approached to Alinco Kanpur also. They kept the prosthetic arm for about 2-3 months, and then they decided not to take it forward. They said, you give me the complete drawing, then we will manufacture it.
Trial 1, a water bottle half filled with water. Trial 2, a water bottle fully filled with water. Trial 3, 2 water bottles, both half filled with water. Trial 4, 2 water bottles, both fully filled with water. The results of the experiment demonstrated Enrich's lifting capacity. After conducting the trials, the weight of the water bottles lifted was measured using a weighing machine. The accumulated data revealed that Enrich could lift a load of at least 2,150 grams. After successful laboratory testing, Enrich was tested with 8 upper limb amputees in the Regional Institute of
I'll stop this thing here. So one message I wanted to share with all our faculty colleagues and the upcoming student generation. See, in the laboratory proof of concept, of course it takes time, but then taking it to the commercial level is an havoc task. Possibly that's 1/5 what we do in the POC level. Like this device for Nayan is more than 15 years, right? For last 4 years, he has been given 1 crore, and then another 70 lakhs have been given to these 2 companies to come up with the industrial design, but they have not yet promised to take it to the market, right? So at least another 5 years to go to estimate very broadly, no? So if we would like to see the India to have the products, particularly hardware products are very difficult actually. Even for my product, Robo Analyzer, which Professor Behra has mentioned at the beginning, we created 2009, it has commercialized only 2022, and now the company is telling, sir, what about the upgrades? If I don't give the upgrades, it will have its own natural death in next 2-3 years actually, you know. Even though IIT has earned about 30-40 lakhs out of royalty for the sale of that software. So this is something we have to keep in our agenda. So I would request INAE to consider how to inbuild this aspect. Like one of my agenda at this age, is a senior, to create new generation of faculty. I remember when I was undergraduate students or just doing masters, that time, we hired Professor Faruqi at IIT Kanpur has a project. We started asking, what is project, right? So now came of those days. So now we are talking about the startups, right? And now we have to talk about the commercializations, right? That's the buzzword we have to build in along with AI. So that's the startup already has shown. So this is maybe I'll just show what lab you already aware of. So Ayurveda, I wanted to show it. So again, since lots of AI buzzword is happening, so Jadavpur University professor along with his student came up with this MetaSpec device, very cute device. So we also invested about, I think, about 1 crore to this. And based on some AI algorithms, you can figure it out the quality of the drugs. And one of the students doing some postdoctorate in Thailand, so he is about to sell about 10 such pieces as a part of the joint project with the prof there. And the left hand side, the T-saw, this is drone-based delivery of cornea. So that is the first demo done in the country. And now with ICMR, we are having a meeting and dialogues how drone-based delivery can be working out. Technologically as such, not much difficulties, but procedurally, legality-wise, there are a lot of difficulties. For example, Delhi is a red zone, and if you fly a drone, you will be probably shut down. So the concept came from ICMR secretary that can we think of drone ambulance concepts. So where maybe the drone could be intelligent enough to be detected as an ambulance purpose use and not to be shut down. So TSAW is one of such companies. We have about 10, 12 startups working in the drones, and this is one of them. Sure. And so this is the READY program, Research Entrepreneurship Development for you. This is our pre-incubation program, quite successful at this moment. We take undergraduate students, final year students, and for those who graduated in the last 2 years, they are also eligible. So we allow them for 6 months with all the funding they require. So as you can see, there are about 29 people came, and few of them have converted them to startup companies. And this teleoperation is one of them which is going. So there is one for the blind people, and the bottom one is the Vitakion, which is going to Antarctica, and the smart prosthetic socket, not that 9 Kakuti one, but the other one. And this is very interesting one, a breath analyzer device. So this is the one which is, if you come to AIMS, it can be demonstrated. So in one such lecture series, I was showing to the crowd, and one of the doctors from Rajiv Gandhi Super Speciality in Delhi, he has been to Antarctica. Then he proposed that it will save a lot of life. What the problem there is, many times if the scientists who go for experimentations there, if they somewhat feel bad or they suspect something, they have to be airlifted, which is very costly affairs, right? They said if these kind of devices can do the diagnosis, and they can decide whether they have to be airlifted or not to be airlifted. So it would be a lot of cost saving things. So this is upscaling, as already mentioned, so I just fast forwarded this. These are the two main centers came in the video. So left hand side we have a drone 50 km away from IIT campus, Sonipat, which is a green zone. Center is a medical cooperative center with IIT Delhi, with their facility we created, and these are the 10 co-innovation centers who are doing exactly what we are doing it under our kind of guidance. So that's the end of this. We incubate, we accelerate, we mentor, we connect. The future is with us, and we are HFC. And this is Karsi 9 Kakati, who used my software to write thank you, and my mobile is public, so you can take a snapshot and catch me anytime you like. So thank you very much.
Any quick question? Couple of quick questions. So what is my question is that after 5 years,
Yes.
so what is your plan now in terms of translational research?
Very good questions. At least targeting 2 products to be brought into the market in next 5 years. So one, this prosthetic arm is pretty close now. Then another one, we are thinking of this plate bending machine or the servo motors, which Amit Jain is doing it actually. Okay? And rest, of course, you people have to help as a Grand Project Coordinator to give us the direction. Okay, if you patch this and that, you can get one product out of it.
Yes, please.
Quick question.
Yeah, please.
So there is a product which says breath analyzer for early diagnosis of diabetes.
Right.
So is there a possibility of increasing the scope of this particular
Yes.
device or the range, sir, and how does it work? What is the
Okay, so I have to come back to you to give you the details. It is one of this READY program as mentioning. So it is a student's idea. So he has been given whatever money he wants, maybe 50,000, 1 lakh, and then his sustenance survival cost 25,000 per month, right? So he said without having any pricking or anything, so just from the breath he can test the sugar level and stuff like that thing. So yeah, so we can enhance this possibility.
So thank you,
Thank you.
Professor
Thank you.
Sir,
Thank you.
for your wonderful talk, and on behalf of the organizer, we have small.
I'm here tomorrow also, so anything you can catch. Thank you. Thank you.
So now I invite the next speaker, that is Subhajit Roy Chaudhary. He is from IIT Mandi, professor, also project director of the iHub at IIT Mandi, which is SCI, Human Computer Interface. Professor Subhasit Rai Chaudhary did his PhD from Jadavpur University, and he's a recipient of University Gold Medal in 2004 and 2006 for his BE and ME respectively, and he also received Young Engineer Award by Institute of Engineers. Is a recipient of RIFA Young Faculty Award in 2015, Young Neurologist Award from the World Stroke Organization in 2015, and COMSIS Young Achiever Award in 2025. So his topic is cyber physical system based non-invasive brain stimulation for rehabilitation of patients with mental stress and depression. 25 minutes and 5 minutes for the question answer. Thank you.
Mouse? I think it's touch screen.
It's just minimized.
Oh.
You can just put it.
This one. There's one. Yeah, this one. Yeah. Thank you. Thank you, Professor Behra and everybody. So I would like to deliberate for the next 20-25 minutes on the different issues with related to mental stress and depression, and how we can usually we can make use of this point of care testing devices which are low cost and affordable, as has been also elucidated by my colleague Professor Ajay Agarwal in the previous session, that the healthcare scenario in India has to change and move towards low cost affordable diagnostic techniques. So I will focus primarily on the same area, and but of course oriented towards mental stress and depression. Okay. So I would like to acknowledge the support led by my students, because they are working and I am talking. So what is a cyber physical system? It's basically a physical and engineered system whose operations are integrated, monitored and controlled by computational core. The computational core typically operates in real time, and in most cases they can be reconfigurable as well. So nowadays of course a thrust has also gone towards using this FPGA based computational cores for this diagnostic systems as well. So if you now see the US scenario, you can see that a huge amount of thrust has been lent. It's not towards the healthcare, and if you see the Indian scenario on the other hand, these are basically the figures which basically motivated my line of research. So 700 million Indians live in 636,000 villages, and only 2% of the doctors stay in the rural areas. On the other hand, 66% of the rural Indians do not have any access to critical medicine. 31% of the population have to travel for more than 30 kilometers seeking healthcare facilities. 22 million population is pushed down below the poverty line because of healthcare expenditures, and 40% of the healthcare expenditure is funded by borrowed money or sold assets. On the contrary, it has been found out that preventable and curable diseases dominate the morbidity pattern. This is something which we should definitely make use of. So I start with some manuscripts of Tagore. You can see that two of them are written in Bengali, one in English, but over here we are more concerned with the manuscript rather than the content of the manuscript. You can see the way Tagore wrote his manuscript. Usually when we write something, do a pen through, again write something, again do a pen through, whatever. But this pen throughs of Tagore is something really remarkable. That is, you can see that he has stitched and weaved these pen throughs into some cohesive pictures. The first one is the picture of some plant, the second one and the third one looks like some snake, whatever. So this is something which of course shows the level of his creativity, not just creativity in terms of the articles written, but also in terms of the pictures drawn out of those articles, which is So we actually come across to this notion of that, I mean, what we see as his performance is basically an outcome of his creativity, and you really need to have a great mind to have great creativity. On the other hand, if you see the real scenario, people, these are excerpts from pictures of software industries where people are having a lot of depressions. So this is basically what we popularly term in today's language as workplace depression. People get depressed with the kind of work they do from dawn to dusk, the same kind of coding work, same kind of stereotype work, with which they get depressed over time, and they need some kind of rehab over time. I begin the story with the story of this 12-year-old girl, Abha, who was climbing on a rock at a place called Mukutmanipur in the Bankura district of West Bengal. It's basically on the tip of the Chotonagpur plateau, where he was doing some rock climbing, and then she had a rock fall, and she became unconscious while doing the rock climbing. And unfortunately, because there was no support available over there, she had to be rushed all the way to Kolkata at the Institute of Neurosciences. And when she was brought to the Institute of Neurosciences, she was diagnosed of an irreparable brain injury, and there was a hemorrhage, you can see in the picture, and she had to succumb to it. And by the time she was brought to this hospital, she has already breathed her last, and she could not be given another life after that. On the other hand, had this thing been detected on time, a simple surgery could have been done, a simple insertion could have been done, and that hemorrhage been taken out, she could have been saved. But this is not the only case. There are lots and lots of Abhas in our country. On the other hand, India has one of the lowest number of MRI scanner, perhaps one per million of population in the country, which is one of the lowest in the world. If you do the math, it comes out to be, in terms of neurological disabilities, that approx 3.5 million people are getting affected by neurological disabilities annually, and on an average it comes down to 11,000 per day and 7 people per minute. And this is not the situation in our country, it is the situation in so-called developed countries as well. You can see the picture of a 42-year-old lady, Anita Trevik. She had some brain hemorrhage, which she misinterpreted as some kind of a headache. And in India, we have something like a tag like Saridan Khao or Sardard Se Aram, whatever. So she also had took some medicine like that, and she was taking it for the next 4 days, and she was not getting any relief out of it. And then when she went to the hospital, she was diagnosed of some brain hemorrhage, but luckily it was not like the other case. She could have been treated for the next 6 months, and then she could get back her previous life, with some restrictions, of course. Globally, 11.6% of the disability adjusted life years and 16.5% of the death are reported due to neurological disorders, of which stroke actually comes at the forefront of the list, followed by migraine, epilepsy, and other disorders. Even in advanced countries, the neurological, 40 to 50% of the neurological emergencies are missed by the doctors. Now, if you see this report from the Nature Reviews Drug Discovery, we find that this cognitive impairment is not just there for only stroke, but also for stress, anxiety, and depression. All of them have one factor in common: cognitive impairment. And it has been also found by research that stroke, anxiety, depression, stress, these are actually mutually related to each other. So, so people have looked into the neurophysiology of it, and we found that there is something called the neurovascular unit, consisting of the neuron, the blood vessels, astrocytes, and the microglia. So the neurons and the blood vessels are connected by something that is called neurovascular coupling, in which one of my PhD students in fact worked on this Yashika Arora. She graduated in 2021. So where we found that when you give an electrical stimulation at the scalp site, that can be coupled to the blood vessels in terms of you can constrict or dilate the blood vessels, which is called arteriolar compliance. So the arteriolar compliance can be controlled by means of transcranial direct current stimulation. We started off with the DC stimulation, and now we are of course working with random noise stimulation as well as alternating current stimulation. And then we found that similarly, by controlling the flow rate of the blood in the blood vessels, we can also control the cortical excitability in the brain, which was confirmed by the EEG results. So this coupling takes place with the help of another kind of neuroglia cells, that is called microglia. And then we found that we reported this work in Frontiers in Neurology in 2016, that we can also look into the whole thing from the excitation inhibition point of view, and where we could basically relate the whole phenomena with respect to the balance and imbalance of the sodium potassium ions and the cerebral oxygenation level at different places in the skull. Now if you see the global technology map, we already know from our knowledge of these COVID times that a plethora of such medical devices have already invaded the market. We have the pulse oximeter, we have the glucometer, we have the blood pressure measuring unit, and so on. However, there is no such devices that can monitor the brain at the point of care. On the other hand, in case of a neurological emergency, it is very important to rush the subject to the hospital and get the subject treated within a golden 3 hours. Suppose that someone has got a stroke, you get a window of 3 hours to treat the subject and give the right injection, whether it's an ischemic or a hemorrhagic stroke, in order to save the life. So time is extremely critical in case of these neurological emergencies. So we started off with by taking a small cap, the same cap which our students like to wear to play the cricket, and we made some small holes in it. And then we inserted some silver chloride electrodes over here. Unfortunately, the pointer is not going because it's a TV screen, the pointer is not there. So you can see at the top left corner the picture of the cap, and we inserted silver chloride electrodes over there. And then what we did is that we gave some weak direct current stimulation. So the physiological limit for current density is 250 ampere per meter square, whereas we maintained a current density as low as 0.526 ampere per meter square, which is way below the physiological limit. So the patient didn't even feel that some current stimulation was given. Now, the idea of giving this weak direct current stimulation is to modulate the arteriolar compliance, and then we found out that if the person has got a lesion site where there is a constriction or some obstruction in the artery, that part doesn't get dilated, but the other parts get dilated and increases the flow rate. So you can see that there is an increase in the cerebral oxygenation level, and you can see the red part gets bulged out, which means the oxyhemoglobin gets increased, and once you give the stimulation, and from which we can see that by giving the stimulation you can dilate the cerebrovascular artery and have enough amount of oxyhemoglobin concentrated over there, which can increase the cerebral oxygenation level. But it does not cause any change in the lesion site, and this could be used as a biomarker to classify between a normal and stroke patients. Then we found out that when we are giving the stimulation, even by using a ring or disc electrodes of great companies like Soterix or Covidian, we found that the stimulation was reaching to the gyri of the cerebral cortex, but not to the sulci, that means the trenches of the cerebral cortex. But we needed the stimulation to reach to the sulci of the cerebral cortex. So again, we re-engineered these electrodes to have the silver nanodots on the surface of these electrodes, and with that we could actually make use of the fringing electric fields to reach to the sulci of the cerebral cortex. We basically went back to class 11 physics to re-engineer these electrodes and ensure that the electric lines of force could reach into the trenches of the cerebral cortex. And now you can see that once you give the stimulation could reach to the cerebrovascular fluid, which means that it goes deep into the sulci of the cerebral cortex. But then when I presented my work before the Stroke Consortium, which was hosted by the TCS in 2017, they literally blasted at me. They said, what work you have done? Unless I am able to classify whether the person is suffering from ischemic or hemorrhagic stroke, that work has got no value. So again, we went deeper into the problem to find out the ways of classifying between ischemic and hemorrhagic stroke, and we found that usually for ischemic stroke, the constriction or the agglomeration of the fat in the artery, it takes over time. So you can see that the cerebral oxygenation level, you can see that green line, it is gradually decreasing over time as more and more this fat material is depositing in the artery. Whereas in case of hemorrhagic stroke, where a sudden burst happens in the artery and blood gushes out, you can see a sudden drop in the cerebral oxygenation level, which you can see from the graph here itself. We did extensive work on this and in our lab and also at PGI Chandigarh, and published this work in IEEE Census in 2022. Subsequently, what electrodes we developed in our lab, we have actually a center for fabrication of electronic devices, where we can fabricate our own devices, and whatever electrodes I talked about was fabricated at our lab at IIT Mandi only. Then we did animal trials with it. We basically tested those electrodes on rats. At that time, we didn't have in-house animal testing facilities, so we did the testing at IHBT Palampur, which is actually a CSIR lab. And then, so we what we did, we basically exposed the rat to stress factors for 14 days, 2 weeks. So we kept the rat in a cage, shaked the cage, and also exposed the rat to continuous illumination for 2-3 hours, because of which the rat got stressed. And on the 15th day, we did a EEG of the rats to see the status of the rat, and we found that the power level of the EEG, average power level of the EEG declined, which showed basically the stressed or depressed level of the rat. Now, in order to, and then we also confirmed it by 4 kinds of cognitive tests, like the open field test, force swing test, novel object recognition test, and sucrose preference test, to see whether the rats were actually depressed or not. Just a small example, if we take the sucrose preference test, a normal rat would prefer a sweetened water as compared to a normal water, whereas a depressed rat, for a depressed rat, it doesn't matter whether the water is sweet or normal, unsweet. So likewise, we actually did all these 4 tests. If you want, I can discuss in detail later on, but because of the limitation of time, I cannot go into details for those cognitive tests. What I want to say is that we actually on the 16th day, we actually slaughtered the rat, took out the brain, and did a neurohistopathology of it to see what is the situation of the neurons in the gray matter. And then what we did is that we basically divided the rat into 2 groups. One is the control group and one is the treatment group. For the treatment group, we gave the transcranial direct current stimulation using our developed electrodes, and we found that for this treatment group, the amount of degenerate neurons, the degeneration took place because of the depression, the density of these degenerated neurons got reduced for the rats which were stimulated by electrical stimulation, and whereas the depressed rats continued to have a larger number of degenerated neurons. You can see that in the last graph that once you give the HDT-DCS, there is a decrease in the concentration of degenerative neurons. Now, what is actually happening behind the, if you look at the science, so when we are giving the electrical stimulation for more than 7 minutes, there are some lasting changes happening in the neuron, which we call neuroplasticity. So now when a stroke happens, some part of the brain gets totally damaged, we cannot do anything about it. But there's a larger part around the stroke region which gets partially damaged. Our objective is to give the electrical stimulation and get back the normal functionality of the partially affected region, and that's what we targeted at using this neurostimulation process. So we actually went for this TDCS facilitated neuroplasticity, and we found that we got significant improvement in the results once we give the neurostimulation. We gave it up to a period of 25 minutes with 1 milliampere of current, and this was actually as per the recommendations of the ethics committee at IIT Mandi as well as ethics committee at PGI-MER Chandigarh. And so we did this experiment at that time with anodal TDCS. Now we are doing it with TACS also, transcranial alternating current stimulation, and we are also getting better results because we have another flexibility of playing with the frequency of stimulation. Previously we were only playing with the amplitude of the stimulation. Now we have the flexibility of playing with the frequency of stimulation as well. So we actually developed, based on our findings, we developed a physiologically constrained gray box model to capture the neurovascular response of transcranial direct current stimulation, where we considered 4 pathways once you apply the TDCS. One is basically in the synaptic space, one is in the astrocytic intercellular space, then in the perivascular space, that is the space surrounding the blood vessels, and also the smooth muscles lining the cerebrovascular artery, and we saw its effect on modulating the vessel circumference, which we call the arteriolar compliance. So essentially it boils down to the problem of applying electrical stimulation and modulating the width of the diameter of the cerebrovascular artery. Of late, we are also going for another adjuvant treatment over and above this TDCS, that is using Indian classical raga. We identified 8 ragas like Rag Bhairavi, Rag Bahar, Rag Kedar, Rag Darbari, Rag Bhupali. So we have identified 8 ragas which can be used as an adjuvant over and above this TDCS for treating subjects with mental depression. So we tried 4 kinds of tests, that is no TDCS, no raga, only TDCS, only raga, and both raga and TDCS, and we got maximum results when we used a combination of TDCS and raga. But now we are actually looking into the process of how to give this TDCS and raga dosage in the pulse mode, in an alternating mode or overlapping mode. We are basically working on engineering with the TDCS and raga to see what is the effect of overlapping the 2 dosages in different ways. So in this process, we essentially what I want to develop is basically a personalized healthcare for neuro rehabilitation. Every individual, just as every student in a class requires an individualized teaching, individualized guidance, so also every patient requires an individualized treatment. So we started off with the neural cortical neural mass model and the thalamic neural mass model, and developed our own thalamocortical neural mass model using the excitation inhibition hypothesis, and then used it as a inspiration to develop this control system, as you can see in this feedback control system that we developed, where we are based on the notion of a Kalman filter, where we are deriving the feedback out of the EEG and functional neuroinfrared spectroscopy signal. We now have both the EEG and FNIRS facilities available in our lab at IIT Mandi. So we are basically using this NIRS and EEG to uptone or downtone the stimulation and have a personalized healthcare strategy for every individual. So this is the work that is currently going on at IIT Mandi, how to develop an individualized treatment strategy, both for treatment of this mental stress and depression, and also how to cure the sleep disorders, which has become very common of late. So these are the questions that come to our mind. A plethora of cyber-physical systems have flooded the market. How far are they effective in terms of personalized healthcare? The physiological processes under neurovascular coupling still remains largely unexplored. We are of course going into deeper and deeper into it, but can we explore them so that we can plan for individualized treatment plan? Arteriolar compliance can be controlled through cortical excitation and vice versa. So how far is this controllable? And FNIRS is definitely a much lower cost alternative than the one that is popularly used, that is fMRI. But
In terms of penetrability, FNIRS has got some limited penetrability capability. Can we work on these lines to ensure that FNIRS replaces fMRI down the line so that we can have a low cost individualized treatment strategy for for stroke patients and other mental disorder patients? Can we diagnose stroke at the point of care? So I leave it to you to think instead of thank you.
Thank you. Thank you, Sojit, for your nice talk. Question? Yeah.
Yeah, yes, please.
How do you target specific areas of the brain? So far, like you may be talking about some kind of an area which is some specific area. There are many different areas where the different functionalities of the brain take place.
So currently we have a 256 channel EEG in our lab, which with which we can actually monitor the different areas of the cerebral cortex with a high level of granularity, right? So similarly, we also have a 28 channel NIRS in our lab, with which we are monitoring it with a high level of granularity.
So it can stimulate any of these areas?
Yes. So we are using the cap that is developed by RTNS, but we are using our own electrodes in it.
But how deep you can go in terms of
That is basically the limitation we are currently having. We can go up to maximum 1 centimeter or so, but then suppose something happens in the cerebral medulla, there of course still fMRI is the solution to those problems. So that is where the big challenge lies, that how we can further work on needs to increase its penetrability. If you of course reduce the wavelength of the electromagnetic radiation, then the penetrability increases, but then it can be carcinogenic also. So that's actually some optimization problem to solve.
Yeah.
Yes.
You mentioned that you are trying combination of electrical stimulation and raga. So what I understand that electrical stimulation is like a rhythm signal. Raga is like the audio signal. So
Yes.
combine in the form of a pulse simulation.
So what I said is that the electrical stimulation is given over a certain time frame. So we started, what I showed over here is basically in the overlapping time interval, we are giving both the electrical stimulation and playing the raga. In fact, to further share with you, we have seen different results if the person himself sings versus if the person listens to the song. When you are singing, you have a different level of immersion into the whole thing, whereas when you are listening to the song, you have a different level of immersion, right? So the experience is different when you are listening to it and you are singing by yourself. So that also we found out. But now what we are trying to do is we want to see in disjoint pulses, that suppose you are playing raga for 2 minutes, followed by TBCS for 2 minutes, again followed by raga for 2 minutes, or maybe some other period of time. What is going to be the effect? Right. So we are actually currently engineering that. Yes.
Yes. Just a comment actually. There is a lady doctor Shweta Adatya. She is Dubai-based, Indian doctor. She has a lab called Limitless Brain Lab.
Okay.
So your raga and this effect, I think she does a lot of those things. Maybe it could be useful for you.
In Dubai.
In Dubai.
Definitely. Try to make.
So I was asking this, that see, this effect will be person dependent.
Yes.
So have you looked at how it varies?
Yeah, I mean some of the subjectivities we have looked at.
Yeah, but that's why exactly, since it's a subjective, is there any parameter by which you can quantify that whether something will be impactful? For someone, maybe music with stimulation would work better. Okay, for someone, music may not really contribute.
Yes.
Okay, so these kind of categorization of the classification have you looked at?
Because sir, we need a huge volume of data to go for this categorization. The same thing which PPC also told me at the end, that for this personalized thing, the one
You need data.
Yeah.
But the point is that if you are
currently we are with the dearth of data.
But if you have the human ethics approval,
Yeah.
for doing this examination, then you can use on a large number of people, you can carry out this test.
You have to collect.
No, but then the person has to volunteer also. That is a big problem.
Volunteer, but volunteering is also can be various ways. Because if there is a guarantee that there is no impact or there is a equivalence, but you can get, what I'm trying to say is that you don't require thousands of samples to start with.
But at least a few
hundreds you require. But if you're really talking in terms of personalized, then that issue becomes very important.
Yes. So that is the thing, because one of the biggest challenge that we are facing is that even though we have this ethics committee approval and whatever, we can for all these treatments we need the person to come and visit us after 7 days window. So we actually had a project with DRDO for giving stimulation to soldiers to boost up their morale, and many of the people, our students and whatever with whom we did some trials, they dropped out after 2 or 3 sittings. Said it is very boring to sit for 2 hours and all that, because for this EEG you have to make that person sit for 25 minutes in a dark room and have a dark adaptation. That single thing is very boring for the people. But then I am very rigorous about it.
Possibly you have to work out an experimental protocol, overcome these, if this really has to move into a translation.
Yes.
Okay, let's give a big hand to Professor Chaudhary. This is on behalf of INAE, a small token of appreciation. Thank you. So we have the third and last talk of this session, and I invite now Professor Prasanna S. Gandhi from IIT Bombay. He is currently Professor in Mechanical Engineering and Professor in charge of IITB Monas Research Academy, also of Suman Masruwala Advanced Micro Engineering Laboratory at IIT Mumbai. He received his master's degree from IIT Bombay, PhD, Rice University, both in Mechanical Engineering. He started his independent career at IIT Bombay in 2001. Current focus of Prasanna's research group is on dynamics and control of ultra-flexible mechanism, robotics, polymer and ceramic 3D microprinting, control of fluid instabilities for spontaneous multi-scale manufacturing leading to applications in microprinting, microfluidics, medical robotics, products and devices. Some of the technology developed in his laboratory are transferred and licensed to ISRO, a few private companies and startup Flex Motion Technology co-founded recently. Among other honors, he is a recipient of Robert Lowry Patent Award at Rice University, Boycott Philosophy of Government of India, Professor Isaac Fellowship, Best Faculty Award in 2008, FIE Foundation Award at IMTEX 2019, PK Pattovardhan Technology Development Award 2021, SIR Technology Translation Award 2022, Dr. Abdul Kalam Technology Innovation National Fellowship 2023, and Chandrayaan 3 Honor 2024. Towards social commitment, he has been a certified teacher of stress relieving, art of living techniques since 2010, making a positive difference to the lives of students, householder and professional life. Professor Jan.
वर्क फुल करेंगे तो आ जाएगा, शेयर करेंगे, फुल करेंगे शेयर हो जाएगा।
लैपटॉप है ना,
ये आ गया
सुनिए ये बताइए। ठीक है, क्या ऑप्शन क्या है नेक्स्ट? नहीं विजिट वर्क
ये लगा देंगे कंडक्ट
पॉट नहीं है, पॉट
USB-C है,
पॉट नहीं है।
मेरा कनेक्टर है, ये USB-C है।
ओके वेयर इज
You have USB to USB-C?
यस, लेट मी चेक।
Okay. Right, I think this is okay. Sorry for that small technical interruption. Thank you very much for the nice introduction, and I also thank organizers for giving me this opportunity to share some of the interesting research that is going on at our laboratory here. This is a place where our research goes on, where a lot of activities happen in collaboration. We are always open to a lot of different collaborations with industry, academia, and other institutions alike. And a lot of activities are actually driven by the experimental research. So in my lab, typically the innovation starts at the experiments. Okay, once we get nice experimental results, then we look at into the theoretical aspects of it. Rather than going the other way, you do theory and then just to kind of see the theory works or not, you just perform experiment. So it's a different way of dealing with. So our students they first do hands-on in the lab, and then they kind of start getting into the depth of the theory little later. So this is like an outline of my talk. I'll first kind of delve upon what are compliant mechanisms, just a brief idea, then why they are so important, and then I'll give you a brief outline of various different applications that have been developed in our laboratory for many industrial and maybe research problems to be solved. Okay, and then I'll kind of I've already shared my slides also with the thoughts for what can be done in this area further, and in general for what is good for the country to kind of happen in the innovative way in this domain. Okay, to solve some of our industrial and robotics and space technological problems. So these compliant mechanisms, as the word suggests, consist of the links or joints which are compliant in nature, or they are flexible in nature. Okay, and because of the motion of these elements, because they are flexible, they can bend. That bending motion is causing actually some kind of interesting dynamics in this kind of mechanisms, rather than having like a pin joint or the slider crank kind of a joint. Okay, so there's a lot of research going on in this domain, right from topology optimization to kind of get certain kind of directions to mechanisms and things like that. However, there is very little kind of industrial appeal to these, except for a lot of these different products that have come in the market, which are based on staplers and other kind of a thing, which are used which are using this compliant kind of mechanisms. But real industrial kind of manufacturing systems and other domains, there is a limited kind of exploration so far, and that's what we are kind of developing in our laboratory. Why that is so, I'll tell you in a bit, and what are the different advantages that these mechanisms bring in. That also I'll say right now. So these mechanisms, they give, because the motion is because only of the bending of the linkages. Okay, so there is no friction, no wear tear that is happening in these when these mechanisms work. Okay, so that gives them very unprecedented advantages of very high resolution, then superior repeatability, no backlash, no friction. That's why there is no lubrication necessary, no maintenance necessary. Then there is a low weight, so it's low inertia. That means you can drive with the same power, much higher speeds. Then there is no wear and tear. There is no noise because there is no friction rubbing against each other. There is no noise in the systems. So there are so many advantages from the industry perspective. And they are very long lasting because now there is no need for maintenance. So some of the mechanisms working in our laboratory are for 15-20 years. There are nothing no kind of a performance degradation we can see over the time period. So that's why they have a lot of these different advantages that they bring in, but also along with there are challenges in the mathematical aspect of it. That their analysis is complex and the dynamics is complex. Then control development is challenging for them, and we'll see some of the ideas that we have kind of played around with. And then manufacturing of them are some of the challenges, and that's what we have overcome them by some of these research that is going on in our laboratory. So I'll give you a glimpse of some of the applications that we have developed, and from there one can see, from the research one can see what mathematics or what kind of challenges would have been solved achieving those kind of applications. So this is some brief outline of the basic compliant mechanism that is used for producing perfect straight line motion. Okay, so if you have simple cantilever kind of a mechanism, you can know that when you apply a force, it bends like this. Okay, and this bending is not in a straight line fashion, obviously. Okay, there is a rotation to the block, and as well as the motion is along some kind of a circular path. Okay, or curved path, if not circular. How do you kind of take care of this? You apply one more kind of a link. You put two links in parallel to each other, and then when you apply force, then the links will bend in this the minimum energy configuration in this kind of a fashion, where there is the rotation of the block is gone now. Okay, but there is still some kind of a parasitic error in the axial direction motion that is happening. So this is called single paradigm compliant mechanism, and then we can use similar kind of a configuration on the other side and create this double paradigm kind of a compliant mechanism. And now we can see that if the motion happens, it is completely straight line motion for the block under interest. And this is what now we use for creating a lot of these industrial applications around this system. And then we'll look at similarly some kind of a rotary versions of this system where we want to produce a rotational motion which is perfectly straight line with the remote center of motion for the system. So we'll touch upon that later on. So now I'll directly delve into the applications that we have developed, and one of them is this 3D microprinting kind of a system. Okay, so this is where we have invented other kind of a method for scanning, which is based on the linear scan rather than the galvanous scanning that we might have observed in some of the printers that are commercially available. So here we use, instead of the galvanous scan, we use the linear scan. So the lens and this mirror are moved. This first mirror and the lens are moved together along the laser path to get one kind of a direction of motion, and then other direction of motion you get by moving the entire three lens, two mirrors and one lens system along the other laser beam path. And then so that's why you can kind of scan entire area. This is one of the patents that we have filed on this kind of a scanning method, and this now kind of maintains the laser spot here on the surface at the focus at all the times. Okay, so this spot at the focus here will be all the time, wherever it goes, laser will go, the spot will be at the focus. As against the galvanous scan, where the path is traversed along a sphere. Okay, because the focal distance of the lens is constant. Okay, so this kind of a way is making sure that you are able to kind of move the beam focus spot on the planar kind of a surface. Okay, very perfectly, and that's how the resolution. When you kind of use this for the printing or some kind of a scanning kind of a processes, the resolution will be very high. Okay, so you don't compromise the resolution at any point in the system. Otherwise, in other systems, only the center will be a highest resolution, and other places you have to do some additional kind of a thing to maintain the resolution. Okay, so these are the advantages that this kind of a scanning system brings in, and we now use compliant mechanisms to do this kind of a scanning. Okay, so without getting into the details about I'll just show you some of the results here. So these are the results of positioning, where like you get a nanoscale, nanometer kind of a positioning accuracy just by using some kind of a control algorithms which are not really very hi-fi non-linear kind of algorithms. Okay, still we can get plus minus 100 nanometer accuracy very easily over the travel range of about a few mms. Okay, and this is a system where you can see the video of the system working. So we are producing this kind of a mechanism, this kind of a component here. You can see the hexagonal pattern with a comb kind of a shape here, and then you can see the compliant mechanisms up here. Okay, and you can see the motion. The linkages are moving here. Okay, that is one kind of a scan, and other kind of a scan is because of these linkages you see here. That's the Y motion here, and overall you can see this kind of motion happening here. Okay, as you kind of zoom in into that, you see further details of the structure that is appearing as the laser scans. And so we have all this kind of a embedded hardware and software that is developed for this process to happen. Everything is developed in house, and we can do this. So this has given us a lot of kind of flexibility to kind of do the controls in a very interesting way for different kind of scan paths and other kind of things. And this kind of generates this component of this kind. And you can see here now the direction, third direction motion here. The Z stage is this, and this motion happens intermittently. Once one layer is getting scanned, the next layer is prepared, and then that is getting scanned. And that's how you build layer by layer the entire three-dimensional component. Okay, and these are the different kind of 3D structures that are developed based on this kind of a technology. Okay, so they give very high kind of precision in manufacturing at a micro scale. Yeah. This is the second kind of a system that is developed now based on some similar kind of ideas, but flipping over the way we fabricate now. Instead of one layer, now there is a open substrate, open kind of a unconstrained photopolymer available. So what you are doing here is we are focusing on the substrate on the top, on the bottom of the substrate, and photopolymer vat is at the bottom here. Okay, so as you scan here, in this case, you will generate these shapes at the bottom here. Okay, so now you can control the intensity while this is happening, or you can control the speed of the motion while this is happening, and then you can try, you can kind of start affecting the shape that is getting formed here. Okay, so that is the idea of this term bulk lithography that we have coined in the literature now. And with this, we can have many different possibilities of the structure that coming up. See, one of the challenges in the previous process is the layer by layer kind of a process is you get a stair stepping effect. You have one layer to other layer, there is a step that is happening. Okay, especially if you have a slant kind of a geometry, then the steps are very evident. Okay, so this is avoided by this process. Okay, so the kind of components that you get are very interesting here. So you can get this microneedle kind of a fabrication kind of possibility, or some kind of biosensors or diaphragms that of different thickness or varying thickness, that can be possibility here. So these are some of the structures that are fabricated by this kind of a process. Okay, so you can get microfluidic channels, or you can get this very smoothly varying kind of a structures. So you can have the surface contours mapped very nicely by using this bulk lithography process. Okay, and one of the spin-offs of this process is fabrication of these micro needles. Okay, one of the micro needles you can see here. Now we have used these to kind of create micro needle patches. I'll talk about that. So this is a micro needle that you see here. So this is a 20 micron geometry, and you can get very sharp kind of a micro needle by virtue of this process. So we have studied entire kind of a particular process of this micro needle fabrication in using Maxwell equation, basic physics of matter and light interaction, photopolymer light interaction, considering the diffusion of photoradicals there, and then we can predict the shape of the needles that can be formed. So you can see the shapes are varying, you can see some bulging happening here. Okay, there is some kind of a constriction and then bulge happening here. So these kind of shapes can be controlled by using some parameters of the process. the process happens is very simple. You have a laser shining on the mirror, and then like on the lens further, and it focuses on the bottom. And now here we are moving the photopolymer vat itself to kind of create this needle from one place to other place. So you just shine a laser spot at one point, and the needle will form there. Then you move the photopolymer vat at other place, and then at the other point you can shine a spot, and then you can start kind of getting these multiple needle arrays. So these micro needles, as you know, if you have a mosquito bite, you hardly notice, you don't see any pain, but doctor gives the injection, it's a big pain. Okay, so now you can imagine that, okay, you have hundreds of mosquitoes sitting on your skin, and they're delivering you the drug. Okay, so this is a kind of a way to kind of do the drug delivery in the future. Okay, so you have a drug patch which is attached to your skin, and it is slowly kind of getting absorbed in the skin. The drug along with the needles, they'll get absorbed in your skin and in your bloodstream, and then they'll deliver you the drug. Okay, so that is the kind of a scenario that we are kind of building these systems for. And there is already a lot of research going on in this area currently, and the biggest pain point in the research currently is how to fabricate them in a mass scale and easily. Okay, and this is where our process comes in handy for such a kind of a thing. We are kind of developing this system into a product now to kind of have a desktop kind of a machine which can print you this kind of a microneedle patches templates, and then from the templates you can go to do the molding and multiple kind of a drug needle patches you can create. And we are collaborating with INSTEM to kind of test it on the mice skin and for the diabetic kind of application. That's the main application where patients have this difficulty in pricking their skin multiple times in a day for maintaining the insulin level in their blood. So that will be very useful for that kind of those kind of patients, and also for people or for the children where they're scary of the injection. Okay, so those places this will find quite and also our rural areas where there is a scarcity of skilled nurses to kind of administer the injections. Okay, that's where these patches could be of help. Okay, then other product is this micro milling machine that was again it uses these compliant mechanisms here, and based on use of these compliant mechanisms, you move the substrate, and then you have a spindle which is kind of creating and mill or milling is done by this spindle, and then you can create components like this. Okay, this technology was licensed to one of the companies, and it was displayed at IMTEX 2019, and it kind of was appreciated by Free Foundation Award to that company. This was honored. So you can see really fine geometries can be very nicely created because your position accuracies are really fine here. Okay, other kind of industrial automation, we have intervened for one of the companies to they wanted to have they're encoder producing company. They wanted to have very fine kind of a machining done on the surface of the plates where the encoder reading plate will be mounted. Okay, and then that accuracy levels needed was to be done in a very fast manner, so that the production line is not getting disturbed. So this was my main critical component in their production line, and that's where we intervened and gave them the solution where you can see this compliant mechanism is holding the tool, and this compliant mechanism, because of its compliance nature, it can detect small changes in the touch very easily. Okay, so the tool touches the surface of the disc, and that touch is registered, and now you know the reference level, and you know the cut that is to be given to the disc, and it automatically gives that cut. Okay, so you can see here that cut is detected now, and the machine is approaching to kind of give the cut, and it starts doing the machining operation here. Okay, and this is done multiple times to kind of get to a proper level of the, so this currently this machining is going on. So all this is done automatically in the assembly line now. Okay, so this is what the solution we gave based on compliant mechanisms to this company. and similar kind of a thing can be done for available for other kind of applications. Possibility do exist. Okay, and so this auto touch detection is happening within 10 microns kind of accuracy. Okay, so it's really good. Now next thing is this compliant mechanism for universal testing machine at the micro kind of a micro and nano Newton force measurement and displacement measurements. Okay, so that's what we use this kind of a a very highly compliant kind of mechanism that you see here. Is a very large deformations that are happening. So I'll not get into the details of there's a whole theory for these large deformation mechanisms to kind of analyze with. So that we have used to kind of generate the simulation models for such a kind of a thing. And now this works for measuring millinewton to micronewton kind of a forces in force displacement kind of for say nowadays there is a flexible electronics that is coming up in the market. So you want to kind of test how the flexible electronics will work under such as small forces or bending forces. This kind of a system could be useful for detecting giving micro and nano Newton level forces to the substrate or some devices and then test them. We have used them for testing this the silicon rubber based sensors that were developed for the resistance sensing. Okay, so these sensors had carbon powder and carbon nanotubes inside it, and they are very flexible kind of a sensor. So very small force will kind of stretch them, and with the stretch you can detect what is the stress with the stretch the carbon particles will go apart from each other, and then the current that is flow in that will change. Okay, and that current flow was one of the kind of characteristics of the stress that is there in the system. And to know how much stress we are giving, we can have use this kind of a UTM for that purpose, and then we can get the full kind of a calibration of that sensor done by this machine. So this again no such kind of a unit is available currently in the market. Okay, but there is a lot of need for such a kind of a thing, and we have been able to kind of develop this. But I mean, as again this technology is available, and the productization and commercialization is what is the way forward to go. That's where we are looking for some partners to kind of do that. Okay. Then this is another technology where we have developed the scanning probe for coordinate measurement machine here. So you can see this is a linear scanning probe which can move in XYZ direction here. These are X stage, Y stage and Z stage, all are compliant mechanism stages, and they are somewhat kind of decoupled from each other. Okay, there is optimization done to kind of decouple from each other, and that's how we can detect very fine kind of a touch and motions also. That's why it is an analog scanning probe CMM, and this can detect the touch to the level of accuracy of about 20 to 50 nanometer kind of a level. Okay, so you can really do a good surface accurately surface measurement. Of course, not the surface finish, but the contours of the surface within that accuracy. This is a new process that we have developed in our laboratory, and for that we needed this some kind of a mechanism which can kind of make the two separate plates separate from each other with the virtual center at one end of the plate. Okay, this kind of a plate separation is what was needed here. Okay, as if the plates are hinged to each other, but there is no physical hinge that is present there. So for that we developed this one of the compliant mechanisms and then complete setup around that to carry out this process. I'll first explain you the process, and then you'll appreciate this much better. The process is very simple. You take a high viscosity fluid drop, put it on first plate, and then compress it with the other plate. Okay, and then now you have a thin film of the fluid that is formed. This is about 20-30 micron kind of a film that is formed, stretched between the two plates, sandwiched between the two plates, and now you separate these plates angularly. Okay, what is going to happen is the air will start rushing in from the sides of the film, but film will not go back as a drop because it's a viscous plate. And that's where there is this famous instability called Chapman-Taylor instability that sets in. and the fluid film, which is circular, interface which is circular, is broken into multiple places, broken at multiple places, is punctured at multiple places, and the air starts rushing as the fingers into them, and then that kind of starts relieving some kind of a patterns on the surface, and these patterns are like these fractal geometry patterns, and they are very useful for biological applications. Okay, so all the systems in our biological world, we see them as a fractal geometry, fractal like geometry, like one vein splits into multiple times, and then they come back. Okay, you take our respiratory system or renal system or whatever. So this the nature has that kind of a geometry for a reason. Okay, the geometry now people have studied and found it to be very efficient in energy. You don't need a lot of energy to kind of have the processes of gas exchange or mass transport that is needed for this process to be done with this kind of a geometry. And now we have this process to kind of produce the geometry very easily. But there are problems in the thing. There are some kind of a controls that are necessary. That we'll see how we can get them. Okay. First, I'll show you this video of this mechanism, how it works. So you can watch. This is you see there. Here is the actuation that is happening. This actuator coming, pulling down. This ball will touch this plate here, and then it will pull down. And then you can see this link, which is kind of tilted in some kind of a fashion. Okay, which has 90-degree bend and then it's tilted. And when it is like this ball brings it down, this plate is like attached. This mechanism is attached to the plate at this point, and then this plate is lifting off the other plate as if it is hinged at some point of the touch at the plate. Okay, that's how this happens. Okay, it doesn't slip in this direction on the surface. Okay, this is what is the beauty of this kind of a compliant mechanism here. Okay, maybe I can play this video once more, like to kind of see. So you can watch this point. Now it comes down slowly as we actuate, and then this plate gets lifted off, and it gets lifted as if it has a center somewhere here. Okay, so this is like a remote center of motion that we have created here with this compliant mechanism. Okay. So with this we can create a lot of interesting kind of features on the surfaces. Okay, so I'll kind of show this in the form of this video here. Okay, so how this process starts and how this really happens. So we call it shaping of the fluid. Okay, in some kind of a shape, and retaining those shapes further for different applications. So these shapes will be retained further by using we use this photopolymer liquid to do this shaping. And then we use UV light to cure them, to kind of solidify the photopolymer liquid. The process, as you see, begins by putting some kind of features or marks on the plate, and these marks are what is the main control for creating very interesting geometries. Okay, you lay this liquid on the surface, which is alumina slurry, alumina plus some kind of photopolymer kind of a slurry, and as you can see the slurry on the top here, and now this plate will come up and it compress this fluid here. Okay, so this fluid will get stretched in the form of a film. In this plane, you will observe this fluid is kind of getting stretched. In the top view, it is getting forming a circle and touching all these kind of holes that are created on the sides. Okay, so now if you use some kind of a controlled kind of a parameters for the separation, then these holes will be preferential pathways for the air to get into the plate, and that's how you can create the geometries that you want. Okay, so you can place these holes at places that you desired, whatever geometry you want. But depending upon that, you can place those holes, and then you can get many different kind of geometries like these. Okay, and they are since it is instability which is now somewhat kind of controlled, it is spontaneous process, so you don't really need a lot of time to kind of have this process happen. So this is very small time you can get many interesting geometries, and this is not restricted by the area or volume what you fabricate, because if you maintain some non-dimensional numbers, you'll kind of get it over whatever area you want. Okay, So this is like scalable, completely scalable kind of a process that can be used in many places for surface texturing or creating microchannel geometries. We are using like many different applications we have developed around this process. Okay, so I'll not have time to talk about that because our focus is on compliant mechanisms, but I'll show you some geometries that are fabricated here. Yeah. Okay, sure. We'll finish. Okay. So these are some of the, like you can get as regular geometries as hexagonal shapes and things like that. Okay. So that is another kind of a interesting aspect to this process. Now we come to like the displacement amplifying dynamic displacement amplifying compliant mechanism, which where like you give some kind of a input to one end instead of like giving input to this end as in the previous cases, and now you can keep this mechanism in some kind of a oscillatory motion. And this is now similar to what happens to your pendulum clock. Okay, you need very small energy to kind of maintain the oscillation of the clock, right? You give once you give some kind of a input, then like with the small input, every cycle the system keeps on running. Okay, and that's why like these systems now become very energy efficient kind of systems. It brings down the energy to kind of do the 3D printing very drastically. Okay, and that's where what we are infusing it into this probably India's first kind of a 3D microprinter based on such a kind of a compliant mechanism system called Spanda 1. Okay, and here we are kind of like developing this system as a commercial kind of a unit here. Okay, where we'll have entire embedded system software inside the thing, which is currently under development, and the system is already proven to kind of print the component that I have shown you. The next is compliant mechanisms for the remote center of motion in the rotary kind of a fashion. So I'll not get into the details about that, but here you can see it working. So this mechanism, if I give any force on the top kind of a thing, it will move as if the center is up here. And this is kind of useful for like eye surgery robots, where you are inserting tool from the eye, surface of the eye is where you want the center of rotation should be, and then you can maintain that by using this process, and you can do very precise kind of a surgery by robotic kind of applications with this mechanism. Okay, this is another kind of application for the digital torch sensor. Okay, the same kind of a rotary concept here, where this we have encoder here to sense the rotation of the top disk related to the bottom disk, and these are the compliant elements, and that's what will determine your the torque of the on the system. And this is like a digital output rather than the conventional strain gauge based analog output. So this is very accurate kind of a force measurement or torque measurement system that will be possible here. And we have already demonstrated and used it in sensing the torque of the harmonic drive that we are developing in our laboratory. This is like system for the eye surgery kind of robot. This is another interesting system with a high compliance in the linkages we are using for creating this leech inspired robot. Okay, where the one block kind of holds it to the ground and like pushes the other block around it, and then like that block will hold it to the ground, and this block will lift up, and the robot will keep on hopping like that. Okay, and idea is to kind of see if we can develop this into completely dynamic system with a gymnastic kind of a motions possibility. That's what is currently going on. And this is compliance in harmonic drive. That is what we are controlling here. And I think we'll not delve too much on this. I'll want to kind of show you some kind of videos about control and dynamics of such a system, where you have these systems. These are very highly flexible kind of ultra flexible linkages. So fundamental understanding of these dynamics and their control is what we have been doing for long duration now. And you can see that this system has this central equilibrium unstable and two side equilibria which are stable. Okay, so it will settle in one of these equilibria eventually. But what we want is really to how do you control the unstable equilibrium here? Okay, by moving this card. Okay, that's what is a control problem we challenge ourselves with, and then that's what we have developed the control. If you see this, if you give this card some kind of a sinusoidal kind of a input, then this is a chaotic system. Okay, you can see this Poincare map that it shows here. Okay, you don't see the motion happening here as a harmonic motion. Okay, it's completely random motion that happens here. okay, and it's actually shown to be chaotic kind of a system. Okay, so this is like the point kind of maps in simulation and experimental, and then we develop energy shaping based control strategies to kind of control such a system. Okay, so I'll just show you a video of how it happens here. So this is like a simulation of this to happen. So our control problem is to stabilize this unstable equilibrium vertical, and also to take the car to some kind of a position, and that's what happens in the experiments also here now. Okay, so we start. I'll show you from beginning. So the experiment starts here. Okay, and you can see that by measurement of the stress at the bottom here, we are able to kind of give that feedback with the complex mathematical processing, which I don't talk about right now, which is called energy shaping control, and we can stabilize this unstable equilibrium here. Okay, and that's what I want to kind of say. Thank you very much. So I acknowledge all the funding support and all my students, especially.
Thank you, Professor Gandhi. Questions?
Yeah.
Yeah.
So one query I have with respect to this macro-level
Right.
So many a times it requires that whatever drug delivery you do, it has to be done in a very quasi-static and controlled mode.
Right.
Is you have to monitor the vitals in a closed loop and adjust the dosage of the injection of the drugs.
Right.
So how are you?
So right now it's so that's the next level. We can use now a closed loop to kind of have the sensing also done by some kind of a microneedle patches part. So microneedles can be used for both for sensing and delivering. Both places can be possible. So we can have that system having on a patch. But right now we are starting off with just one passive system where okay, roughly what you need, and then you can take it from there. Yeah, that's interesting question. Yeah.
Anybody else? How did you control that inverted pendulum?
Okay. So this is a strategy called energy shaping control. So we use we see right now for the system as it is has a potential energy lowest in the side, right? So we can create some kind of a energy potential, virtual energy potential, which will have a energy least in the middle. Okay, so then if that energy potential it is created, and then around that energy potential we now can see to have that energy potential, what is the input I need to give to the card so that the virtual energy potential will maintain.
But how to do that to actuate the motor in the cart?
Right. So you finally get what you get is the cart acceleration from that energy potential analysis.
Okay.
Once you get that acceleration, you maintain that acceleration by using a motor.
Okay, let us thank Professor Gandhi.
Thank you very much.
Thank you for your interesting talk, and this is a token of appreciation from INAE. Thank you. Thank you. Thank you.
We thank all the speakers for the enlightening talk and the presentations. We appreciate their effort and time into putting these discussions, and before we close this session, a special word of thanks to our session chair, Professor Lakshmidhar Behra, to skillfully guide through the sessions and efficiently facilitating the discussions. So we now part for the high tea. The high tea is being arranged just outside the VH lawn, and we resume our technical session 3 on industrial automation at 4:30. 4:30.
Good afternoon, welcome back after tea, and hopefully we are still awake to listen to the talks. Let me introduce the session chair for this industrial automation. Dr. N.C. Murmu is currently director of CMRI, CSR CMRI Durgapur. He is a PhD from ITBHU and also postgraduate degree from ISC Bangalore. He has a number of awards to his credits, including Vasvik Award, and his contribution in terms of technology developments in CMRI and earlier his term he was when he was with NAL Bangalore is noted, and it's always credited for various initiatives. So it is actually we are lucky to have him, and he actually agreed at a very short notice to chair this session, and I think his chairing would also provide kind of inspiration to the participants.
Thank you, Professor Choudhury, for nicely introducing me. So we will start with our sessions. Professor student class update. So we have made little changes just to accommodate. So Professor Dasgupta is a professor in microelectronics and VLSI, currently serving as professor in IIT Roorkee. And he did his PhD from IIT BHU, and meanwhile he has the skills at University of Wisconsin Madison, few residents, and so with that just I request Professor Dasgupta.
Good evening, all of you. And I know it's post-tea, as Professor Choudhury was saying. Hope all of us are awake for at least for the half an hour I speak, and of course for all of the candidates. And thank you, Professor, for allowing me to swap the places I would like to catch. So I thought of since this is a very heterogeneous crowd coming from various backgrounds, I have kept a topic which is energy efficient, real-time cyber physical systems using compute in memory. So I will introduce to you the compute in memory. This is our main building, which you see, our James Thomson building, so we are 175-year-old institute, and this is the main administrative building which is there at IIT Roorkee. So I will introduce to you, give you a basic idea about, so slightly it will be technical in nature. So I will give you a brief idea about the 6-transistor SRAM cell, then maybe give you a slight insight into logical operations of SIM, Mac operation, design challenges, and then the work which we have done at IIT Roorkee, I will just propose it using that. So we have been listening to wonderful talks since morning, and it has always come to our mind that as Dr. Somnath was speaking in the morning itself, currently it is data driven rather than anything else, right? So basically the person who owns and able to manipulate data in a proper manner wins the race. And that's the reason this compute in memory has actually come into picture within the cyber physical systems. Be it robotics, be it any of the human computer interface, smart cities, smart cars, drone technology, you name it, and everywhere you will find that it is driven by data, which means that typically you will have a very, very large subset of data to work with. Now, in a typical integrated, from the electronics perspective, again I'm saying electrical engineering point of view, typically if you look, you do have this design, development and deployment sort of picture for any subsystem and CPS which you use. And we are currently at IIT Roorkee working somewhere in the intersection of model validation and model embedding, which you see on the blue one and the green one, light green one on the top right picture. What does it mean is that currently we are trying to deploy a large amount of memory devices for CPS systems, and that's what we are looking. So typically, if you look at the left-hand side picture on the left-hand side, it says you there's a constraint, right? So what are the constraints? Constraints are power and energy. These are really big constraints in IoT systems. We work on that, have a purpose for it, and then the approach will be to use those constraints to our advantage and try to do a cyber-physical system and AI integration to a larger extent. The last diagram which you see on the big side is showing the application domain of the cyber-physical systems AI integration process. I will be talking primarily on the computing limit side. If you see, since this pointer does not allow me to point it here, but it typically somewhere in the computing limit which we'll be talking about. Okay, I can use a mouse, right? So this is the computing limit part which you see we'll be talking about. All of you are aware of the fact that every time you put a search engine in Google, you are actually spending certain femtojoules of energy somewhere across the line, be it server or anywhere else. If you go to San Jose and look at Google servers, they are typically so large. In fact, their cooling systems are more costlier than their server running time. The cooling system, they invest too much on the cooling system. So that's a big takeaway from discussion is that if you are able to reduce the number of femtojoules per unit operations in a system, you will be in the winning side. So that's the reason the computing limitation has been set in that manner. So very in a broad sense, top approach, we are looking at low latency because using a real-time data system. Enhanced security as an important one as well as privacy. You require high bandwidth efficiency will be required. Of course, improved reliability, which means that any data which you are going to process, the input of the data you don't have control, I agree, but the processing controlling will be there with you only. So you should be able to provide improved reliability of the output result with the minimal downtime required in a network system. These are very important in smart city projects. In fact, they are already being applied. For example, Smart City Moradabad has already started with Smart City Lucknow, just nearby. They have already introduced this point of improved reliability and low power consumption. So these are all edge operations. Edge operations basically means wherever you have a computing device, the operation is being held at the edge itself, which means that you require very low power and energy efficient systems to be developed. And that's the reason you see the last point, that SIM is compute in memory. I will come to that maybe one slide later on, which is the key enabler for cyber-physical systems. This is where I was talking about to you. Those who are new to this, I'll just give you an idea. Till now, when you look at typical von Neumann architecture, you have this memory array here and you have a processor here, right? And you have address buses and data buses which run through the memory array and the processor. Now, with the advent of such a huge database, buses are now almost obsolete. You cannot actually handle so large data across these buses, and that is known as von Neumann bottleneck, right? And with heavy data intensive areas, the von Neumann bottleneck is coming into picture, and you're not able to transfer data. So a very ingenious method came in. This came around, the SIM concept came around 2010, around 12 that came. And what this thought was, can we build the processor within the memory itself? That is known as compute in memory. So if you have a processor which is working, you just have to embed it within the memory, right? Once you do that, you can work it as a memory under certain signal systems, under certain signals, and it can work as a processor or as a logical operation in certain systems. So if you see on the right hand side here, we have an SRAM array. This is the conventional one. We have a SRAM array which stores data. You do have a read write, and then you do a digital signal processing. Currently in SIM, what we are trying to do, this blue line is getting inside the SRAM array. So the SRAM array consists of both SRAM array as well as readout circuitry, which will do MAC operation and logic operation. There are many names to it. We have in-memory computation, SIM, compute in memory, and so on and so forth. So therefore, this reduces data transfer and helps in improving energy efficiency. There's a parallel processing happening. The cost you pay for it is something amount of what is known as security. Security is an issue here, and security systems for these computing memory needs to be generated. I will not go into details of this one. those who work in this domain know that I have typically when you work with DNN, you work with certain layers and you have certain weights attached to it. The idea behind the SIM application for any application is that you do a feed forward inference here, then you try to form an error. So you take the feed forward inference, you get a data, then compare the data with the known data, see the difference. If the difference is positive, you feedback in such a manner that you reduce the difference and you go on doing it a repetitive iterative process. While very easily said, doing it on chip is a very difficult task, right? On the right hand side, if you look at this graph here, this is the memory array which I was referring to. This is basically a 6 transistor SRAM, static random access memory array here, with a word line driver here. So you have word lines here which switches on, and these are known as bit line drivers which drives the memory. So there are word lines and bit lines, and using these word lines and bit lines, you can choose any one bit of memory within this W11 to WNN cell. And then what you do, you take all these data onto these bit lines and then throw it in the mux. You do an ADC, analog to digital conversion, do a shift and adding control, and then you get the output from there. This is a basic diagram of any DNN approach which you do on a compute and memory principle. This is give you a global picture of how memory has been used in SIM. The first operation is basically here, if you look very carefully, is the bit cell structure. Then you relatively have the digital SIM here. So there are two, I will come to that later on. We have a digital SIM, which is digital approach, and another analog SIM, which works in analog domain. Both are very important and used across the board in many applications. Where you will find the applications, and not only find, they are already being used. They are used in CNN, KNN, AES, and in classifiers. They are used very randomly and very in a much detailed manner. The good point about all these discussion is that they are actually realizable, and the chips have been taped out with specific applications in mind, with very low latency and very improved power efficiency. Now let's compare between analog SIM and digital SIM. So on the left hand side you have a digital SIM here, which computing is either done in a boolean 0 or a 1, whereas analog takes continuous from 0 to VDD. Advantage of digital SIM is very simple. 2 states, I can define any system in 2 states. But the number of states which you can define is relatively small. An analog SIM, between 0 to VDD, if I am able to cut a sample, say I have 1 volt, 0 to 1 volt, right? If I am able to sample it by 0.1 volt, then 0, 0.1, 0.2, 0.3 and so on and so forth, I can actually have effectively 10 states being defined by analog, right? So that's the reason you will see that computational efficiency for analog SIM is much higher as compared to that of digital SIM. The accuracy is of course lower because you are playing with such a large number of voltage levels, and the voltage levels are very close to each other, mind you. So one is 0.1, another is 0.2. So even if there is a small noise introduced, you will actually swap from one data state to another data state. So that's the advantages and relative disadvantages which you get. Of course, digital SIM has much higher accuracy because of the digital nature of it, and speed is much higher as compared to analog SIM. Again, the same thing I have repeated here, but just for reasserting the whole idea. One is typically the conventional one which you see on the left hand side. This is near memory, where the DSP block set is kept very close to SRAM block. It is not inside the SRAM block. Physically speaking, you have interconnects being routed from the SRAM bank onto the DSP block sets. But the last one is the game changer, which is basically deep in memory or memory design, where you actually do the mixed signal processing within the memory block itself. We don't separate the mixed signal block separately. Please understand, this block is the most power hungry block of any SIM. The mixed signal block is the most power hungry block, right? It works first of all in analog domain, so it's power hungry in nature, and this is where the whole game is changing between the near memory and the deep in memory computing. Now, why SRAM? The first obvious question asked is why SRAM? Why people are actually looking into SRAM? It's very simple and straightforward. Two things goes in favor. One is, if you look at the last column here, I am comparing this. This is a conventional memory which you all know: DRAM, SRAM, NOR, NAND, flash memory, and so on and so forth. On the right hand side is basically my emerging non-volatile memories. For example, PCM, phase change memory, RRAMs, MRAMs, FE-RAMs and FE-FETs coming up in a big way, by the way, in neuromorphic computing. But sticking to SIM, you see your write energies are of the order of femtojoules. Extremely low. You will never find femtojoules across the network. Only FE-RAMs comes closer to it, but the amount of write energy, which means if you write 1 bit of data onto an SRAM cell, you are spending approximately 1 to 2 femtojoules, 10 to the power minus 15 joules of energy, right? And so the energy requirements are very, very low. That is one thing. And the second is that if you look very closely, the read and write times are also very small. So latency actually reduces when you work with SRAM. These are the two major advantages which works with SRAM, which does not work with SRAM, you should also know, and that is the first one, the cell area. 6 transistors, you understand? So there are 6 transistors there. The cell area is very, very large, right? In industry, for example, if you go to an Intel or you go to Qualcomm, anywhere you go, they are willing to take your design provided you give them at least 2x improvement in the performance. SRAM does exactly that. That it gives larger area, so your silicon cost is high, right? Your silicon cost, your estate, what do we say in VLSI? Estate cost. Estate cost is the land cost, silicon cost is very high, but you are getting approximately 2 to 3 times improvement in the profile of the design. This, I think all of you are aware of, those who are working in electronics. This is the standard 60 cell which I was talking about. You have 2 inverters connected back to back, and you have one pass gate here and a pass gate here. So whenever you want to write a cell, you simply make your word line high, this PG1 and PG2 switches on, and then from the bit line, if you force a 1 voltage, it goes to 1 here. Since it's a latch, if this is 1, this goes to 0, right? Similarly, if you want to store N2 1, make bit line bar equals to 1, then N2 becomes 1, N1 becomes equals to 0. And this is a standard memories design cell which we all know of. However, we have to keep in mind that when we are designing it, you need to do one important point. Look at the right hand side picture here. So basically what I do, I pre-charge bit bar line to 1, and suppose this is 0 here, then what I do is that since this is 0 and this is grounded, the current will pass through here, switch this to 1. When this switches to 1, this automatically switches to 0 by the concept of latch. So these are the 2 important points which you should know, that how I am writing in a cell and how I am reading in a cell, right? And that is done by the 60 cell read operation and write operation. In write operation, we need to ensure that 2 things. So you, for example, in read, suppose a 1 is stored there and you want to read that 1, right? But while reading that 1, if you are destroying the state, which happens in quantum computing nowadays, then you are in a loss. You got my point? That if you have 0 stored here, while reading 0, it converts to a 1. Or if a 1 is stored here and you are reading 1 and it converts to 0, you are in a mess. Because you have actually changed the state of the memory. Not a good idea. So to remove that, we do what is known as cell designing. And what we do is we try to make these aspect ratio of these pull down and pull up transistors, we change in such a manner such that when I read it, my pull down is stronger, I am able to pull the voltage to 0, and my work is done very properly. So both first phase and the second phase which you see here, this is for node 1 dropping and this is for node 2 dropping, and for both the cases I can use a 0 to 1 transition or 1 to 0 transition in the output side. Now this was the first paper which came up, not a paper actually, it was a paper by somebody, but from Purdue University, Kaushik Roy's group was one who published it. And this is basically a logical, this didn't happen any time before. This paper is quite new, 2023-24 paper, Kaushik Roy's paper, where they showed that not only I can do a arithmetic operation on a processor or a memory, I can actually do a logical operation in a memory. So all your logical, your math operation, multiply and accumulate operation, everything can be done on the memory nowadays. So you see here what they did was quite interesting. I have a 6 transistor cell and they used another 2 cell here, M1, M2 here, and by using this cell they were able to design a NAND gate and a NOR gate and a XOR gate, right? There are techniques available to do that. There's a design technique I'm not going to detail, but what I wanted to show by this at least diagram here is that we can achieve a very good output with extreme good fidelity for a logic based design in a memory cell, right? So this cell is read through this word line, output will be a NOR and a NAND gate. So you understand, if I have two 8-bit words being inserted and I want to do a logical operation of comparison, I can do using this sim mode here. The logical operation can be done in the sim, and I can design a comparator using a sim mode SRAM here. So this is the reason I'm showing you this slide. And you can see for 0-0 case, for both NAND and NOR, we do have 1-1 coming into picture. And for 1-1 case, the blue color, it is actually going to 0. The trick is basically with 0-1 and 1-0 case, right? And that's the reason you see here, this for NOR it will be both 0, for NAND it will be both 1. How do you design it is a challenge which you face as far as logical operation sim is concerned. Now, let me show you a basic idea of MAC. I don't have time to show you the whole operation of MAC. MAC is multiply and accumulate. So you multiply one bit with another bit. So you multiply weight with a data, input data, and then you go on adding those data and you get the final value available to me. Just as you do partial product in a multiplication. Now if you look here, if I take my weight to be equals to 0, and even if my input is 0, both these transistors are off, no bit line will discharge, and therefore my variation in the bit line voltage is approximately equals to 0. Similarly, even if my system is off, if my input is 1, weight is 1, but my input is 0, which means my word line is 0, this is cut off, and therefore even if this is on, there will be no discharge, bit line will be approximately into 0. So I have shown you that it is basically 0 into 1 process here and 1 into 0 process here. Let's come to this one. Let us suppose both are 1 here. So my word line is also 1 and my bit line, this one is also 1, which both the transistors are on, primarily meaning that this bit line will start discharging in this path, and as a result the current will flow here, and therefore the output change in the bit line will be 1 into delta V. If there is a small delta V in the bit line happening here, that will result in a very large change in the output set. Now if this delta V crosses VDD by 2, I can have a flip in the data, and this is done very continuously in all MAC operations using 16. So what are the challenges? One design challenge was done by in 2021, and this is basically large overhead and process variation. Please understand, we have not taken into account process variation in all our studies. What is the process variation mean? That when you actually fabricate a chip using TSMC or using you name it, Global Foundries, even our SCL PDK which is there in Chandigarh, even if you do that, there will be always a process variation. Means what you think here, when you actually go to the process, there will be small variation in the value of the channel lengths. Not the channel length is not the big issue. P oxide, oxide thickness of the MOSFET transistor and threshold voltage and so on and so forth. These, if you see, we are working with voltages of the range of 0.1, 0.2, 0.3 or 0.4. Even a small variation will actually shift your voltage up and down. That's a major challenge which was done in an analog sim to a larger extent. This gives you a brief idea about what is the name of signal margin. What is the meaning of signal margin is, if there are two subsequent regions, 0 and 1 here, then the signal margin is defined as the minimum voltage which can be actually distinguishing between two values of a MAC. So if I have a MAC, if there is a MAC which is terminating at 0.5 and I have another MAC coming up in 0.55, then subtraction of that is 0.05. 0.05 volt is basically defined as the signal margin. And this is where analog sim designers try to play with. Try to keep the signal margin to the lowest minimum, so that the difference between the two states can be reduced drastically. You can insert more number of states. So it's something like this. You have this big room, right? You're sitting like this comfortably. Now if I want to introduce 100 more people, what I need to do is I need to shift everybody more closer to each other. Exactly the same thing happens in the analog design. We try to shift the voltage closer and closer. The cost you pay for it is that if your signal is noisy signal, you then step over into the nearby signals, right? And then maybe you are dealing with some data, you will get a falsified data in the output side. That's the cost you will pay here. And that's what is done in the signal margin. And these are the techniques which sort of a read behavior disturb which we show in the signal margin. One important point is that if the signal margin is very high, your full output position is relatively low, right? Which means that with increasing value of signal margin, your precision actually starts to drop down, precision of the output. So you need to keep your signal margin at the lowest minimum in order to ensure that. this is a multi-bit architecture in sim operation. What we do in this case is that, so the way we move forward is that if you have a digital input coming into the system, you do a splitting of the splitting. So you do LSB plus 4, let us suppose there are 8 bits. So 0, 1th bit and the 2nd bit you split, and you split the 4th, 5th and 6th bit, the 3rd slab, and the 7th and 8th bit as the last block. So you play with these 3 blocks. Rather than using all the data together, you divide it into blocks, and name is an input 0, 1, 2, 3 and 4. And for each block, we define the signal margin. So if I say block number 1, signal margin is 0.2. It means that whenever you receive block 1, which is LSB plus 1 plus LSB plus 2, you will always get the signal margin to be approximately 0.2 to 0.3. So you all of us must be aware of that. If the change in MSB is there, the maximum change in the data will be there, right? So allow to have smaller signal margins for block number 3 and allow to have larger signal margins for lower blocks. That's what we do when I say that multi-bit input technique for sim operation is being done. I'll not go into details of this. These are all standard shift and odd operation, partial product generation of computing. So if you know Booth's algorithm, for example, you do partial product. Or even class 12 or even class 12, you should say maybe class 2, 3 kids, when they do mathematics, they do shift and add. So when you multiply, then shift by 1 left, then shift by 1 left and so on and so forth. So you should, so as a designer, while doing electronic chip design, you need to design a shifter also, right? So what does a shifter do? Shifter's full block shifts by 1 bit to the left, shifts another block to the left, and then you do an addition operation using full adders, and then you get the final output. And this is how we do it, and we have solved it using our bit serial approach. This is the overall picture. I will come to the overall picture maybe in the next slide. But yes, this is, I should show you one important slide before I move forward. I have approximately maybe 5 minutes maybe. 5 minutes? I'll just take 5 minutes. So typically what you do here is, in analog sim specifically, you are manipulating the charge, right? So for a corresponding digital input, I have a very specific charge being generated. That charge is stored in this C2C network here. These are all known as MOM caps, MOM caps. Those who are working in this domain will understand. But even the simple capacitors, right? So using these networks, I can actually store the charges here. These charges will get converted to voltage when you actually add them or subtract them in a proper fashion. And similarly, when we do a linear subarray or even a multi-bit weight categorization, we use these switches S1 here, and if you see S1 here. So you see this is 8C block here, this is 7.5C, and this so on and so forth. So what I'm trying to show you is, the whole detail will not be able to explain it properly, but typically if I have a larger cap value at a particular point, using the same voltage, right, you can actually formulate, say for example, Q equals to CV, all of you are aware of. Right? So Q equals to CV basically means C is equals to Q by V. So for a fixed value of V, if you increase the value of C, it automatically means the charge stored there is much, much larger. So as you move from LSB towards MSB towards LSB, you get a much larger charge. And this charge can then be totally accumulated, added, and then converted back into voltage to get the actual value. So this was the final proposed, this came from our group only, me and my colleagues. So this was the proposed 8x8 MAC unit for a MAC computation which we did. And these are the 6 transistor cells which you see here. And this is your switches. So say for example, I loaded all the charges on bit line 1, I don't want to use it. So what I do, I switch off the S1 value. I want to use the charge stored at bit line 2, then I just switch on bit line this S1. As it does, this 1C gets fully charged. When this charge and this 4C charge gets total added here. Similarly, if you get B4 line, you will get this total charge. This goes to an ADC. So what I'm doing is, just to take away from this slide is, you take a charge, add the charge, convert into a voltage which will be analog, fix it onto an ADC, analog to digital converter, and then you will get a digital output in the front side. Cost you are paying for it. These capacitors are not very robust, right? They are prone to process variations, and that's the cost you pay. Similarly, these take very large area on chip, right? That's also a problem. The third problem is these ADCs which you see in green color, analog to digital converters, they are very, very power hungry, right? So when they are very power hungry, they consume the maximum power for the system. So I'll not go into details, I've already discussed. So this was the layouts which we did for a 8x8 bit SAR ADC. So this has gone for a tape out at 32 nanometer TSMC. We have already sent for tape out. We would possibly get the tape out results by January or February 2026. For your information, you can also do it at 180 nanometer, send it to SCL Chandigarh. Those students who are working in this domain can actually, it's a free of cost under SMDP. You can actually use this for doing it. It's all free of cost. The tape out cost on TSMC 32 nanometer for this block comes out to be around 6.5 to 8 lakhs typically. If you lower the technology node down to about 16 or even 14, the cost becomes approximately 4 times, which is around 25 to 30 lakhs for one tape out chip. 32 pin chip for this will cost you like that, except the packaging. If you add packaging to it, that costs much further than that. So these are about 40 cross 40 dimension micrometer dimensions, 60 SRAM cell has been designed. These these MOM based caps which you see here, these are very, very area intensive design. They take up large silicon area. The estate space is very large, MOM cap. It's even larger than you can see as in a 60 SRAM cell. Some of the results we did, we plotted the MAC output voltage with these are all simulated results, please keep in mind. We still don't have the post-fabricated result, which will be available to us in February or March. And we saw the linearity on the right hand side. Then similarly, if you look at the MAC output voltage with respect to the PWM across 8 rows, we got this. This is a nice study which we did. This is known as a process corner analysis. So what you do is that you have NMOS and PMOS, all of you are aware of those who are in electronics, right? So what you do, you make NMOS and PMOS both fast. Then we define that to be as a fast corner. You see, this is the FF corner which you see. Similarly, you have an SS corner which is NMOS slow, PMOS slow. So we try to find out all the corners, right? And if your design passes through all these corners, then it is a good to go design. So any company can take this design from you and use it for their chip. So these are known as corner analysis, process corner analysis. Similarly, we did a post layout simulated one, and we saw there the number of samples was somewhere around 1.9 to 1.09 to 1.1 volt was the mean value which you get. Then we did a Shmoo plot here. The Shmoo plot tells you that yield or reliability, and we saw that the yield and reliability is relatively good for our design, and it comes out to be somewhere around 3.75 nanosecond. This is the access time per cycle on the x-axis, and the green one is the one which chip got passed through when we do. So before we send this design for fabrication, we actually take care of this failed pass design rule. Now let me come to the comparative analysis. We compared with architecture. Our work was relatively smaller. We did with only 22 capacitors, so the area requirement was very small. We did a neural network accuracy test with MNIST, CIFAR 10 and CIFAR 100. These are benchmark databases available online, and you can actually use these databases for doing it. It is accepted across the world that these data sets are benchmark data sets for your computing purposes. And just to give you a brief insight of what we did now was that if you look, these were the various architectures available online, and this was our work which we did. This work we had done on 65 as well as 32, so I'm showing you on 65 one here. 65 gives me an accuracy of approximately 90 and 69. So we are relatively, so this should be around 90, 95 is the typical industry standard which you should have. We are trying to reach across that. However, if you look at the throughput, it's relatively very good throughput which we are getting. This is giga operations per second which you get, and we define throughput in that. And our scaled macro area is relatively 1.45. It is smaller than many of the SRAM cells which we show here. So let me summarize the talk. I've taken about 33 minutes. Let me summarize what we have done till now. Gave you a very brief, it's very difficult to give you the whole idea of SIM in one 30 minutes talk, but The SIM is actually a computing memory, a game changer coming up with major changes happening in analog SIM. Digital SIM is also working in a good manner, but analog SIM is the one where there is a lot of research and students can actually contribute very much onto that. That's one thing area. We are lacking is mapping SIM with the application. That's still a sort of within not only Indian scenario, across all the scenario, that mapping is still a sort of a requirement which we need to do, and optimizing of TOPS and GOPS. So tera operations per second and giga operations per second, how much you are doing to do it. And also obviously the process tolerant variation. So when you scale down your technology node, variability also becomes very, very large. Stability also becomes very large. So these are the few challenges which you will face while going ahead. But as I discussed with you, using simple 60 SRAM cell whose macro is very well defined and stable, I will be able to do good amount of analog computing memory. So with that, I thank you for your patient hearing. If there are any questions, I will be happy to take.
You don't have the right one.
Sure, please go ahead.
You talk about something about the security issues in the scene. What exactly?
So actually, you are embedding now the processor within the memory, and every time you get access to the memory, you are accessing the data. So the security is slightly getting compromised, because every time you access this memory, you are accessing the data within the memory itself. So data is obviously an IP or maybe a secret or something like that. So that way the security is a problem. You are leaving open the security. So there is a group working on cryptographic security issues in SIM. I don't work in that. I'm not an expert in that, but surely that's a big problem which we'll face when you go to the actual application domain.
Okay.
Thank you. Thanks a lot. Thank you.
Now we have next speaker, Professor Deepak Naik. Professor Naik is professor at Mechanical Engineering, IIT Indore. After receiving PhD degree from IIT Delhi, he worked in G Global Research Center, Bangalore, before joining the IIT Indore. And he was instrumental in giving direction to these two CPS foundations as a project director for 2021 to 2025. And his primary research interests include smart manufacturing, reliability, and digital healthcare. He has been recipient of Harry Cambridge visiting lecture fellowship at University of Cambridge, and also distinguished International Associate Award of Royal Academy of Engineering. Thank you. With that, I request you to.
Thank you for the kind introduction. As one of the theme for this conclave is cyber physical system, I will be talking about it especially in the context of production system, what we call cyber physical production system. Just let me ask a simple question. Engineers have created mechanical system, a physical system to help humans in various activity. Why do we need CPS, cyber physical system, where this computational unit for data collection, analysis, feedback and control is integrated with the physical system? That's essentially the meaning of CPS, but why do we need it? Why are we talking about this? Any idea, especially from the students sitting silently in the outside? Why are we attending this session on cyber physical system? Why this is very important?
So because everything our human operation does, it is prone to error, but machine is not that much prone to error.
machine is again a physical system. We have created that. But why we are now adding another layer to it, the computational unit, and wanted it to integrate and work together, where the cyber physical system comes into picture. Probably you are closer, somewhere, you mean that we want to improve the efficiency of our systems. If we can analyze the data, we can work on the data, and probably we can improve the efficiency. But there is another important reason which we often forget for creation of cyber physical system, is that humans or the engineers have realized that systems are not independent. All the systems that we design, be it your AC or a car or aircraft, they are dependent on various other systems. If you take an example of a manufacturing system, a production system, your machine at the shop floor is not an independent machine. It is dependent on various other machines. It may not be directly dependent, but from the operation point of view, it is dependent. So, for example, a machine fails, the performance of the other machine in the line may be affected. The machine performance or the overall performance of the organization or production system is also dependent on the supplier who is supplying the raw material, the quality of the raw material, the inspection process used by the supplier, the transportation system which is in between the supplier and the machine. So, if you want to now optimize your system, in this case let's say production system, you need to consider all this in an integrated manner. It means you need a system of system, and that's where the cyber physical system comes into picture. For that you need a digital system. If you want to create a system of system, you need digital systems. Second thing, see, if you want to improve the efficiency, if some changes happens in any of this element, it will affect the performance of other element. So you want to optimize them together. So for that you need a dynamic system which can identify such kind of changes, and such kind of system, which cyber physical system can analyze this data and react quickly. So if you want to do that, we probably need cyber physical system, which is a system of system. And when we talk about system, networking, communication automatically comes into picture. Ultimately, there should be some value addition. So why we want to analyze, why the quality process of my supplier important for me, whether they have what is the sample size at my supplier end, will it affect? Yes, it affects to my performance. So I want to use that to improve my performance. So there should be certain value addition to it. So we need to identify that value addition. So all this required focus on the system. So in India, cyber physical system ecosystem is now primarily driven by NMICP's National Mission on Interdisciplinary Cyber Physical System. They have created this 25 technology hubs, so each of them are focusing mostly on different technology verticals. But as I mentioned, ultimately we are there to create system of systems, and if you focus individually on the technology, we lose that system of system focus, the value addition focus. So somewhere in some of the hubs needs to also focus on the application area. So in the healthcare, someone needs to focus on the manufacturing, someone needs to focus on the defense, and so on. So that what value addition that particular system want, and how to create that system of system ecosystem for that particular application can be studied and can be analyzed. Coming to the specific application of production, this is a scenario. I interact a lot with industries, visit various industries, and small scale to large scale industries. This is the generic scenario. This cartoon clearly shows that. Why this effort on smart manufacturing, which is nothing. Smart manufacturing is nothing but use of cyber physical system in production. That's cyber physical production system. It is also referred to as Industry 4.0, smart manufacturing, smart factory, and so on. Ultimately, more or less, they are same. I know we can discuss the differences in the terms, but more or less they are same. So, if you go to industries, their fear is that if you don't use this Industry 4.0, something wrong will happen. We will be out of the competition. and so on. But if you ask them why, if you do that, if you apply smart manufacturing, what will happen? So, still the outcome is uncertain. They are not sure. They know that CPS, CPPS or Industry 4.0 or smart manufacturing has a great potential to improve the performance, because when you are considering various parameters using this system or system concept, you can be dynamic, and you are dynamic, you can probably get a better outcome out of your system. They know that, but still the outcome is uncertain when you apply some technology to it. So this happens many times because what happens is because of all these hypes and the keywords and the buzzwords, many of these solution providers, which are mostly the IT companies, big IT companies, as well as the startup companies, they are going to the industries and selling their version of smart manufacturing. Look, I have developed this camera based solution, and this will detect the defect, and it will create a cyber physical system or Industry 4.0, which is not the case. It just does a very small element of improvement, which may even not be useful if it doesn't integrate with any other system in your organization. So because of all these buzzwords and the hype that is created in industry, that the cyber physical production system can lead to very good efficiency, many of the solution providers are coming and selling their own version of it. And at the end of the day, you go and talk to industry, they will say, I have 10 of such solution lying on my shop floor, but they are not talking to each other itself. So that's a typical problem. They are not integrated. And the whole aim of creating value is destroyed here. That's why the outcome becomes uncertain, the last corner of the cartoon. And that's why the industries are saying that the outcome is uncertain. How to overcome this? One of the ways, like the entity like the technology innovation hubs can act as a bridge between the industries and the solution provider or startups, and identify the entire roadmap for CPP. Now coming to how we did it in a couple of places in the industries. But our focus is always, what we have realized is when we talk about CPPS or Industry 4.0 smart manufacturing, the end goal of industries has not changed since last 100 years. They only focus on lean manufacturing. They want any solution which can create a leanness in their factory. That is from the point of view of delivery, cost and quality. So we need to understand that whatever we give them ultimately should help them in improving the performance, reducing the wastage. So an industry leaning approach is required there. With that, we started interaction with MSMEs, small scale industries. Why MSMEs? So in India, we have 19 million, more than 19 million MSMEs. And if we don't upgrade them on their digitalization journey, we can't create such kind of CPPS. Because, see, Maruti being a OEM or the large scale industry, if they want to create a CPPS, they will have to get their supplier onboarded, because most of the product they are getting from such a small scale industries. They need the digital twin of the product that they are buying from their suppliers, and the suppliers don't have that. So then the overall CPPS objective will be destroyed. So that's why we need to first work with these MSMEs, which is very important, and normally they are left behind this journey. In fact, we are talking about all this CPS, etc. And the situation is that these MSMEs do not have an IT department, active IT department, which will ultimately affect our manufacturing performance. So what we did is we worked with various MSMEs. We did various workshops with the MSMEs in Indore region, Nasik region, identified some of the priority areas for them when we talk about our focus at the back end is to develop CPPS, but for them it is just digitizing their shop floor initially. They will not understand all this LLM or other stuff, or understand, but they are not interested. So they are interested in a very basic thing which affects and then gives better performance on their shop floor. So we found that there are various solutions, though it is not readable. Mostly, if you just target top 3 from both the workshop, it covers majority of the issues faced by industries, which involves inventory management, capacity monitoring, process monitoring, etc. If you are able to develop traceability and such solution, if you are able to develop such solutions for them, they will be digitally upgraded. And interestingly, while doing this, we also need to ensure first that we focus on the value for MSMEs. Otherwise, so when you go and talk to large scale industry, they said that do something in the area of digital twin for my factory. When you talk to small scale industry, they don't understand. They have nothing to do with the LLM. They said that, will it give extra money to me? That's the two different thought process in industries. So what we did, we developed assessment model for them, where we started with the objective of the company. So this is, for example, in one of the industry in Pithampur area, Indore area, we asked their priority. They said that getting higher customer rating is my priority. Then we divided this into into sub objectives, which involves quality, low operation cost, on time delivery, and then functions, because ultimately any solution that you propose should add to their function, should be linked with their one of the organization functions. So here let's say maintenance, and then we designed some assessment model, asked some questions, and then got this rating. So we found that traceability, for example, is one of the important solution needed for them. So interestingly, while working for the traceability, we found that the situation in such industries is very different. They, on one hand we are talking about all such technology, and many of such industries even are using paper-based system in the country for process monitoring, etc. How will you upgrade them? So then your various technologies comes into picture. You give them an OCR based solution. Initially we give them an OCR based solution that converted their digital notes into their handwritten notes into digital notes, and then it helped them in some traceability. Then ultimately we propose them and we give them a solution which is an traceability application, which was then translated to the industry with the help of some startup, because so we just develop the architecture and then give the to startup, they translate it. But so on one hand the current situation is like this, then you will have to step by step increase their digital journey. So initially give them a low cost solution, just put a camera and OCR based technology, convert that into digital one. Then give them a better solution, designed a template, a standard template, and capture their data using, let's say, Android based solution that we have done, and the backend integration. So initially you need to just do digitization, then followed by digitalization, where you create value out of this data. So now I have all this data, I could create a value for them. I could analyze which machine is producing more defect, which operator is producing more defect or better outcome. So interestingly in this case what happened is, most of the problems were coming from the product at the end of the shift. You can understand why. So that way they were not able to identify. Also the complaint from the customers were coming, and then the reason was that customer was not using their product in a first come first serve basis, and many of the older products were lying, and then when it was used, then they found that is a defect. So such thing was not possible, but now with the help of traceability it's possible. Then what we said, that you have reached to this level, digitization to digitalization, what next? So we found that by doing just traceability, I have all the idea about that product that they are making. So in a way I am able to now create a digital twin for their product to some extent. Then we said that why don't you go and talk to your customer, saying that I am selling you product, this, let's say, spindle or any other such product, along with its digital twin, which anyway is required for your digitalization journey. So there they can have a competitive edge in the market, because now they are getting such large scale industry are getting not only the physical product but the digital thread also, which will be useful in their end product, end machine, end car, or whatever they are making it. So that's another important aspect here, is that industries need to create a business model out of this, all the upgradation that slowly they are doing it. Just upgrading to adding some technology, getting better data analysis and improving efficiency is one part. But if you really want to do digital transformation, you need the new business model. For example here, can you sell digital thread instead of just selling a product? So that's something that we believe is important. So such kind of solutions where startup plays an important role. When we design the architecture, and someone like a startup will have to take it to the market. That has happened in this case. Second important aspect is when you work with many of the industries in India, in abroad, we have seen we work very closely for all this work in with University of Cambridge Institute for Manufacturing. We found that legacy machines are unavoidable. They are 30 years, 40 years old machine. You cannot just discard them because you want to create a CPPS. So working with a legacy system is very important. After thorough analysis, we found that at the end, to create a digital twin of a machine, for example, what we need is the information about certain events. So then we created an event-based model where for all the events we identified the end event, and for each end event some data needs to be captured. So for legacy machine, we develop a HMI type of system, and then said some radio buttons kind of system we provided them. With that help of that, they were able to get the data from about all the events, but it is still a manual task, but we were able to get the data and do the further analysis. Then recently, one of my colleagues, actually what he did is he put a camera, and then most of the events were getting identified through the camera, and that HMI system which we developed now, they have configured it with that camera. So this has helped not even a small scale industry. Recently one large scale bearing manufacturing industry has shown interest that they want similar kind of system. So working with a legacy system is unavoidable, but you will have to do it. And once you have all the data, we could develop a detailed model of the failure and quality rating of that machine, which helped ultimately in there. Adding value of all the digitalization that we were doing. Another important aspect that we observed while working with the production system or while creating CPPS or various systems is that integration is important. So integration, again, two types of integration is important. One is within the solution, like just doing condition monitoring, diagnostics and prognostics is not sufficient. You need to integrate it. Let's say here in this case, we integrated it with the shop floor policies, for example, the control chart technique that they were using it. So we converted the conventional control chart technique into dynamic control chart technique. With the help of that, using the prognostics, obviously real-time monitoring data and the prognostics of the cutting tool and other component. The benefit was that earlier it took 60 products to identify the faulty state of the machine. Now from the control chart, they were using the conventional X-bar control chart. With the help of this system, we could do or detect that with the 6 faulty product. So that's something that we identified. So integrating these solutions are important. Second thing is integrating the solution with the existing system like MES system, CRM system of the industry is important. So we developed this digital twin for a large scale one MNC making forming equipment in India. The challenge was to actually how to integrate it with their system, the MES system and other existing system. So at the end, we identified that you need to follow all the communication protocols, all the standards. For example, digital twin, there is a standard called ISO 23247, and CPPS there is a standard ISO 23704. These standards, if you follow this, and the concept like asset administration cell, etc., then it will be easy for the integration at the end. Otherwise, your solution will be another solution in their shop floor, which may not be useful ultimately. The last part is, as I mentioned, when we create a system of system, the purpose is that we will be able to make dynamic decisions. Dynamic in the sense because various things are connected, some changes happens here, and accordingly I should be able to make my things, change my policies or planning, so that I get that value from the entire system. for that, no, this is a simple example which where we had 11 jobs, 49 operation, 23 machine. One of the yes, just last slide only. Where we had around this is operation from a factory in Pithampur, and this is the problem size 10:140, smaller problem in still, but with more of such things connected together, when we have system where networks of these devices are connected, many things needs to be optimized together. This problem becomes very large. And if you solve it in a conventional centralized way, it is very difficult. So what we did is we propose a distributed approach, and you can see here the performance of this approach in terms of the time is significantly better than the conventional centralized approach. This is what is required if you want to dynamically acknowledge the change happening in the system. Also, from the objective function point of view, the performance is comparable. In some of the cases recently, what we have observed is even the performance of distributed approach can be better than a centralized approach, because in case of distributed approach, we are able to go inside the detailing of an individual element. That was not happening in a centralized approach. We are compromising on the detailing or the exploration in the centralized approach. So even the distributed approach can be more effective when we work with such system in industries. So that's all. So my suggestions, recommendations as asked by the chair was, so India is around 19.6 million manufacturing MSMEs. We need to acknowledge them while working for the digitalization in production systems. And they need a very dedicated approach. Startups can play a role, but there are certain things that we need to understand. They need a low-cost solutions and a clear path for that. Digital transformation of this, without the digital transformation of tier 1 and tier 2 supply, we can't get complete CPPS for a large scale industries. Legacy systems are unavoidable and need to acknowledge them and use them. An industrial and system engineering approach is important. Instead of just focusing on a small element, we need an entire industrial and system engineering approach. Industries must also come up with a new business model. So one I mentioned that selling the digital twin. Another, which in one of the recent example we created is like customer is normally a paying entity. Can CPPS make them an earning entity, which looks very odd, but it is possible because they can be a partner in the innovation, and ultimately they can get the royalty out of that. So something like this needs to be created by the industries if they want to get the benefit of it. For the students, there are certain research areas in the area of industry and system engineering from the CPPS point of view. Like distributed decision making, intelligent decision support system, integrated prognostics and operations planning, and development of standardized interface for digital twin. So that's all from my side. Thank you. Any questions?
So you can take a couple of questions if you have. Thank you. It is an interesting talk, and especially focusing on the industry.
Thank you.
That you are trying to do. Thank you. We are coming to the last speaker, Dr. Rajalakshmi. She is the professor at Department of Electrical Engineering and currently also project director of Technology Innovation Hub for Autonomous Navigation Foundation at IIT Hyderabad. And she has filed more than 30 patents, over 50 publications, and also the winner of Digital Trade Research 2006. With that told that, and we'll be conclude before 6 o'clock.
Okay. Thank you, sir, for the introduction. I think we have been hearing about the cyber-physical systems from the morning. So we all know, as the previous speaker was saying, it is system of systems. So the subsystems that the system is going to consist is going to be sensing, communication, compute, right, cognition, and control. These are actually going to be the subsystems which CPS is going to encompass and build the system of system, right? So in that context, I am going to build the autonomous navigation as a use case or an application based on which this cyber physical system is built. Okay, so how an autonomous navigation stack, okay, can be built as a cyber physical systems approach. Okay, so in that context, if you see, there is going to be environment, that is the physical system, okay, and a group of sensors. Okay, it can be camera, it can be LiDAR, it can be radar, it can be IMU, GPS, whatever you want, ultrasonic, whatever it is. Okay, a bunch of sensors. Okay, and the next system is going to be the perception system, because like I need to perceive the environment with the help of sensors. So the sensors, maybe one sensor or group of sensors, sensor fusion. Okay, when I say sensor fusion, it can be two-dimensional sensor with a three-dimensional sensor. When I say two-dimensional, it can be camera. With three-dimensional, maybe LiDAR. And now we are talking about 4D LiDAR, 4D radars. Okay, so when I say dimension, again it is x, y, z plus the timing factor as well. Okay, so that way the dimension of the sensor or the data captured from the sensor, dimensionality also keeps changing. Okay, depending upon the accuracy with which we want to work with, okay, we need to fuse multiple sensors depending upon the quality of, the reliability of this system that we are actually building. Okay, so that is the first two part of it. Okay, perception, the outcome of the perception depends upon how many number of sensors I have considered, fused. Okay, and then perception, what are the factors I am going to consider for my perception. Maybe it is, in the case of autonomous driving, maybe I have to detect the objects in the road. Okay, it can be traffic sign, it can be traffic light, it can be lane marking, whatever it is. Okay, so depending upon the use case, again the perception changes, okay, in the stack. And then comes the planning. When I say planning, okay, it is basically, now we are talking about autonomous driving or autonomous navigation. So in this case, the planning is nothing but the routing. Okay, so when I talk of planning, it can be global planning and local planning. Okay, so when we talk of global planning, what do I mean by global planning? Global planning is given the point A to point B, the source and the destination. How do I come up with the waypoints, or how do I decide the route? Okay, so that is going to be the global path planning. And local path planning is in the path that I have considered to reach the destination, if I am going to suddenly encounter some obstacle, okay, maybe suddenly an electrical EB had come and dug a road, dug the road for some purpose, okay, then obviously I have to do the detouring, right? So such kind of obstacles, okay, enables the local planning. Okay, so this is what you call as the planning. Okay, so route planning, prediction, behavioral planning, and trajectory planning. All these things are considered as your planning part. Okay, following that comes the control algorithm. Okay, once I decide the route, okay, the next thing is how do I execute my control algorithm. Okay, mainly when I say the control algorithm, in this case when we are talking about autonomous driving, generally it is 4-wire driving system. When I say 4-wire, it is like brake, steer, throttle and reverse. Okay, so all these 4 control actions, how is it created? Okay, using the planning. Okay, so this kind of control action and the drive-by-wire. Okay, so this complete system, subsystems form the complete cyber physical system when you talk about the autonomous navigation or autonomous driving. Okay, so we are going to see, in the case of driving, how this complete system is put together, okay, in terms of bringing autonomous driving. Specifically at IIT Hyderabad, what we are doing is, we are coming up with this autonomous driving stack. Okay, when I say autonomous driving stack, each of these blocks or the systems have to be optimized, okay, where depending upon the type of the vehicle in which I am actually going to deploy my stack. Okay, so for example, some of these vehicles you see are commercial M1 category vehicles, which have high, which can fly at higher speeds, right? Like maximum speed can be 150 km per hour or so. While if you see these vehicles, these are like golf carts. These are nothing but the camper shuttle vehicles, right? So the maximum speed that this vehicle can go is maybe 20 or 25 km per hour, because they are all not even certified. They don't require RTO certification. Okay, well, these requires all compliances because they are on road. Well, these are kind of off-road vehicles which are used in control environments. When I say control environment, this is campus kind of environments, right? So what we are doing is this: how do you actually fine-tune the stack? Okay, when we are going to deploy on different category of vehicles. When I say different category of vehicle, it can be number of people sitting on it. You know, you see this is like a minibus. It's a 14-seater vehicle. Okay, so the amount of load that the vehicle carries. Okay, the dynamics, it changes accordingly. The control algorithm and the drive-by action have to change, right? So depending the load carrying capacity of the vehicle decides the dynamic of the vehicle, which is very important in coming up with your control algorithm. Okay, similarly, the speed at which the vehicle operates also plays a very critical function in deciding what the control algorithm should be, or how the control algorithm should be designed. Okay, so considering all these aspects, the overall stack, which is actually constituting of these sub-modules, undergoes revisions, or I would say fine-tuning, where the IPs are getting created. Okay, so that's what we actually do as the research. Okay, as part of this, if you see, when we are talking about autonomous driving, the most important thing, people have been working on it, creating lab-based algorithms. There are different kind of platforms. I would say software in loop, hardware in loop, vehicle in loop kind of testings, which as such, research have been doing, or universities have been doing when it comes to kind of autonomous driving kind of applications. Now, IIT Hyderabad, we went one step ahead, where we have also created a proving ground. Okay, when I say proving ground, we have dedicated almost 10 acres of land, okay, creating test track, okay, in which the vehicle can be tested in real field, okay, as per the standards. That is actually the very important thing when we are actually coming up with products, or translating the research into into a technology at higher TRL levels, which can enable, I would say, industrialization or commercialization. Okay, so an in-house stack is developed. Okay, and then we also go with the help of this, I would say, a living lab or the test track or the test bed that is created at IIT Hyderabad. We are able to actually come up with technology readiness levels, which are enabling startups to take the product for commercialization, or enabling industry, either it can be OEM or tier 1s or tier 2s, to take the solutions which is created from the academic universities into a product that can be integrated into their commercial solutions. Okay, so that way I think it is very unique, the first of its kind in the country itself, which we call as the test bed on autonomous navigations. And it's all again Indian Road Congress standards compliant, which is built, and different kind of, I would say, features exist, not only the track, we call it not only for the ground vehicle but also for aerial, because different capabilities exist. When I say capabilities, we have the eVTOL propulsion lab, we have 3D motion capture, which enables actually again drone navigation accuracy testing. Okay, so many such features exist. More details also is available in the website. So this is one of the very interesting lab that is created at IIT Hyderabad, which enables or translates the lab level POC into a product level technology development. So, and it is also the most important thing, open for industry and startups to come and test and develop their product. Okay, that is how it is done. Okay, then comes the next very important thing when we are talking about this complete system development. Mostly the perception part of it. Okay, the AI/ML stack comes into picture. Okay, so when it comes, when we talk about the AI/ML context, again a huge amount of data is required. So that's where we have started collecting a lot of Indian driving data set. Okay, you can see this is our data collection vehicle. You can see there is a 360-degree LiDAR, the 360-degree surround cameras, then we have automotive grade radars, and also there is one very interesting rotating radar on the top. Okay, so this kind of a complete I would say a sensor suite is integrated in the vehicle, and this vehicle recently traveled from Hyderabad up to Jammu, okay, cutting across almost 35 plus cities, collecting a huge amount of data, intercity data, okay, which becomes a huge amount of repository for kind of AIML stack development for perception purpose. Okay, and the most important thing, once you have this, you can see this is the Chandigarh data, fused data, okay, LiDAR, camera view and radar view of the data. And once you have the data, the most important thing is how do we annotate the data, right? The annotation becomes the biggest challenge, and again we are working on coming up with automated annotation tools as well. You can see this for the camera, while there are also annotation tools which are existing for LiDAR point cloud and other point clouds as well. Okay, yeah, so this is one of the product, I would say, as part of the research. We have deployed in the campus. As I was saying, the campus is around 600 acres, in which from the main gate to the hostel circle, it's around 4 kilometer trip. From the main gate to the hostel circle or the academic zone, an autonomous campus shuttle is launched in the campus, on a regular basis, which caters to everybody, a public which enters into the campus, and they can shuttle from the main gate to the hostel circle. The same technology, if you see, this is map based. When I say map based, a high definition LiDAR map is created, because our campus is a controlled environment. It's not going to change much, right? The complete map is created for the boulevard, based on which centimeter level accuracy can be generated, and it is useful for navigation purpose. Okay, so this same technology was deployed also in multiple locations. I would say AP Secretariat and Naval Dockyard and many other places. The same technology was deployed. The next one, what I would like to say, this is for a controlled environment. Okay, whereas if you go for an uncontrolled environment, GPS based navigation is more reliable. Okay, so in that context is this, where we work with an OEM. Okay, this technology was completely GPS based navigation. But the problem with GPS based is our GPS data is not accurate up to the level of centimeter level. Okay, so we have to go for multiple sensor fusion, also have a local RTK base station, okay, which covers a local area to achieve the centimeter level accuracy. But still there are problems, because in urban canyon kind of environment, where there are high rise buildings, there are going to be outages. Okay, in that kind of scenarios, you will see the GPS signals are not available, and the vehicle goes confused as to what it should do as the next waypoint. Okay, so these are the challenges where other sensors will have to be fused, okay, to overcome the kind of anomalies that are created due to this kind of urban canyon kind of solutions. So this is again one more modality of navigation. So one is map based, the other is GPS based. Okay, where the terrains are all well known to us. Okay, there is one more challenge where you do not even have GPS, right? The terrain is also not known. Okay, so in that kind of scenario, how do you do autonomous navigation? That is again a bigger challenge, again, which is one of the very important thing which we are actually addressing. And I'll actually, as we go along towards the challenges section, I will mention about it. The next very important thing when it comes to autonomous vehicles is the connected vehicles. Okay, this is about the vehicle to vehicle communication, more from the I would say the safety perspective. Okay, so this is also one of the very important aspects when it comes to autonomous navigation. So vehicle can talk to another vehicle, vehicle can talk to infrastructure, vehicle can talk to pedestrian to enable safety. Okay, so that is the thing here. Yeah, so again I like to skip all these things. These are different control algorithms. Yeah, going forward, now we are talking about the foundational models, right? So, so when we are talking about the foundational models, huge data set is required. So again, when we are talking about huge data set and creating foundational models for autonomous driving, the most important thing, we need to create kind of handbooks. Okay, when we are talking about the handbook, these handbooks are nothing but the country specific, policies and regulations which are actually governing the motoring law of the country. Okay, so this is very important thing. Again, we have started going through the Moth Gazette and Ministry of Housing, all these things, where we are actually coming up with what is the Indian specific handbook that needs to be created in order to come up with a driving policy for an autonomous vehicle which will be useful for the foundation model creation. Okay, so this is again an important aspect which is going on. Okay, the next important thing in autonomous vehicles is software defined vehicles. Okay, so what is the software defined vehicles? It's more like, it's more like your mobile phone. Okay, you get constant updates from the cloud, right? So similarly, what I'm going to do is I'm going to sell a vehicle version 1 to you. Later on, if some feature want to be updated, it can be updated from the cloud. I don't have to go and get a next version of the car from the vendor. Okay, that is what it is moving towards. The features will get updated from the cloud. So this is what is meaning as what is meant as the software defined vehicle, which is again going to be a very challenging thing, because it also involves a kind of, I would say, programmable E&E architecture. Okay, and also a very high level of cyber security. Okay, so these are very important things. Okay, when it comes to ground vehicles. Briefly getting into the UAV activities, again autonomous drones is also one of the very important thing which we consider as an autonomous navigation stack development. Okay, so different category of vehicles have been worked on. Okay, so important contribution I would like to highlight here is, you can see this is a flight controller. Okay, in-house flight controller. Okay, and also in-house mission planner that is being built, based on which most of these I would say drones are designed and developed. So this is one of the drone which can actually be useful for surveillance applications, and it was also delivered to some of the Air Force organizations. Okay, and this is again an interesting application where a drone which is useful for payload dropping. Okay, and it went for demonstration in Uttam, Jammu and Babani. Okay, where payloads are being dropped at designated locations, not only GPS based location but also on tracking of a particular object. Okay, so the next thing what I was saying, GPS denied or indoor kind of scenarios. Okay, this is again one of the one of the defense projects that we have done. Okay, the other important thing so far is what we are seeing is a small or medium category drone. The challenge becomes multifold when we talk about a drone which is at a heavy payload. Okay, above 50 kg. So because there the open source mission planners, open source flight controllers which come up with their own firmware and other things does not work. Okay, so this requires a lot of R&D to make a heavy payload drone fly with whatever stability required. So we work on this kind of heavy payload drones as well. Okay, this is for cargo application. Okay, and we are also working on something like personalized air vehicles, kind of air taxis. These are all again I would say at TRL levels of 3 or 4. Okay, which are still tested, validated. Validation is still going on. Okay, so this is briefly about the autonomous vehicles research. Recently a book also got published from our group on LiDAR technology for autonomous system. So this is briefly about the autonomous navigational stack development for ground vehicles as well as the aerial vehicles, and some of the challenges or the recommendations going forward. I think foundation model is very going to be very important for autonomous driving. I think many of the OEMs have started working on it. From the Indian context, we have also started some efforts towards that. That's where we were talking about the handbook creation, huge amount of data creation, and the most important thing, the corner cases. We will never be able to go and collect data in reality. So you need to have synthetic data creation also. Okay, so what are the tools by which the synthetic data creation in order to capture the corner cases? So all these are going to be big challenge if you want to come up with an efficient foundational model for autonomous driving. Okay, and the next very important thing, quantum assured navigation. Okay, again we are talking about accuracies in terms of IMUs, in terms of positioning, in terms of sensing. So quantum sensors will play a very important role in the context of navigation. Okay, and the most important thing, digital twin. I think creating digital twins in a controlled environment is always possible. You know, you bring the whatever 3D model you want to create into a lab, use a laser scanner, create a 3D structure for it. That is perfectly fine. But when we want to create a 3D digital twin of an already existing city, okay, the challenge is much more. How do I accurately create it? The challenge is not only on the software or the tools or the algorithms which are going to work on the data, but how do I accurately collect the data? That is itself a bigger challenge, okay, in order to create an accurate digital twin solution. Okay, and again, of course, the regulatory and standardization issues. Going forward for UAVs, I would say, you know, advanced air mobility solutions where urban traffic management, okay, AI-driven swarm ecosystems, and resilient UAV communication networks. Okay, when we are talking of resilient UAV communication networks, under the jammed scenario, where it has lost control with the ground control, it has lost control with the GPS. Okay, what is that the UAV is going to do? Okay, so that kind of completely a resilient UAV communication module, self-healing drones are some of the things which are actually the current R&D and the research challenges that maybe we'll have to focus on when we come to autonomous drones. Thank you so much.
You are completing in time. You can take one question if you have. Okay, I just have a question. Yeah. So one part of it is that, see, this is we are talking about an autonomous driving. But what is also very important in the Indian road context, which in the morning was also discussed, assisted driving.
Yes, sir. Yes.
Okay. Because all of these technologies at various levels can really help assisted driving and make Indian roads safer.
Yes.
So, what is your thought on that, and in what direction we are taking forward?
Actually, if you see what has already released the draft standards for L0 and L1, which is actually ADAS, that is driver assisted system, where 5, 6 of the standards have been mandated for all the vehicles which are going to be on the road from April 2026 for all the commercial vehicles. And going forward, they are expecting for all the M1 category, that is the passenger car kind of vehicles, from 27 April. So, assisted driving is what the government is also focusing in order to enable safety.
But today also you see there are ADAS systems available on high-end cars.
Yes, yes,
okay.
yes.
But now, are those ADAS systems adequate?
Actually, sir, if you see, we have our AIS standards that have been actually formulated and drafted and also now circulated for comments from public. If you see, they are also adopting the same UNEC standards or Euro NCAP standards, which is already integrated in all the commercial vehicles which we are using, you know, but they are not as per AIS standards. Okay, now these have to be fine-tuned or modified as per the Indian context requirement. For example, earlier they were saying, you know, for blind spot detection, the speed at which the vehicle should create a alert is above 60 km/h. Whereas in the Indian context, they have reduced the speed. Okay, so that way there is a lot of fine-tuning. That these, you know, standards that were actually
also possibly validated.
Yes, yes, that is where the current OEMs, service providers task is on.
Okay. Okay, thank you.
Thank you all the speakers for their informative and engaging presentations. We thank the session chair, Professor Momo, for skillfully facilitating and guiding us through the discussions. Before we close this session, a special word of thanks to Professor Chaudhary for graciously moderating the sessions, and request your continued support for tomorrow's session as well. I now request Professor Chaudhary to kindly present our memento to Professor Murmu as a token of appreciation. conclude, you all are requested to join us for the second plenary talk by Mr. J.D. Patil, President INAE at the Outreach Auditorium. Thank you.